Ooh, almost made a mistake. Almost pressed the button to stop the stream. How's everyone doing tonight? Welcome. Happy what's the day? Monday, Tuesday? Today is this is bad. Tuesday. Happy Tuesday, everyone. Welcome to the stream. Welcome back to Mastermind Academy. What's up, Suge White? Always good to see you. In with the Pog Champs. Appreciate that. Hey, Auto Exec. Happy Tuesday. Who else is in here right now? Let me know. 88 Opus, hello. Hope everyone had a great Tuesday. I had a really busy Tuesday. But welcome to the DevOps Bootcamp. Welcome tonight. Tonight we have some fun. We're gonna really learn how to code tonight. We're gonna dive deep. So tonight's gonna be a little bit confusing, but missed yesterday due to traveling. All good, Carson. Awesome. Welcome back. Tuesday it is. Whew, yeah. I should have got some coffee before this. So I'm switching up my schedule a little bit. I'm working out in the morning now instead of in between. So I don't have that energy boost of working out right before. But slide link, yeah. Let's get some slide. Let's get all the administrative stuff out the way immediately. Let's see. Drive. Get into here and the bootcamp. We're on Go Part 2. Let's share them out. There we go. Every time I feel like it's the first time I've ever done it, and I forget exactly how to do it. Save. Anyone with a link can view. Copy link. Let's go ahead and get this shared out. We're gonna give people a few minutes to get in, get settled, relax. We'll get started every night. I think we'll get started around 8:10. So if you're someone who you're cutting it close every night, take your time. We'll relax for the first couple of minutes, make sure we're set up, get the link sent out for this. Every stream, there's always people who are still trying to get into the Google Classroom. So we'll make sure to get people in there. But what are we talking about tonight? Let's pull up the curriculum. Oops, DevOps. Tonight's the fun stuff. So we only have 2 classes of coding with Golang. So we got to move pretty fast. So we learned last time about variables and data types and math operators. We learned we could do math in Golang. We learned a few other things. We were supposed to get into some problem solving with Exorcism, but there aren't any really good problems without learning the things that you know tonight. So tonight we're going to spend about the first hour going over the part that makes coding fun and makes it powerful. We're going to start going over logic operations. So how do you make decisions? How does your application make decisions and do things over and over again? We'll talk about functions and loops and all the cool stuff that makes programming cool. Tonight will be a little heavy on the concepts, on some possibly confusing concepts, but don't sweat it. It'll be fun. We'll get through them. We'll get into Git a little bit, and then we'll solve some problems with Exorcism. Hopefully, I'm trying to get through enough to leave about 40 minutes for just solving some Exorcism problems. So I think we're gonna be good to go there. So good evening. Hey, Long Belly, welcome. Hey, View, go GR, go for heads. I like that. Actually, I don't think I told you guys that the mascot for Go is a gopher. You probably saw it when we went to the Go's website, but that is a gopher if you weren't sure what that fluffy, cute animal was. Took a look at the Google Classroom assignments, but it was a little confusing. Could you possibly take a look at renaming some of the assignments? Maybe something like, okay, at 11420. Yeah, absolutely. So, I think one of the things that I realized when I first started entering all the Google Classroom assignments is at first I thought I could enter in everything and then set it to release when it was supposed to be done, but it didn't allow me to do that. Once you can set dates for things to be released, but it has to be when you first are setting it up, which is super duper annoying. So I will do that. I can start those naming conventions. Absolutely. I do think that makes sense. Especially when there aren't a bunch in there once, especially because it puts things in reverse chronological order. So I think it puts the old stuff at the bottom and it might be a little bit confusing and you got to move your way up. So absolutely, that is value feedback and I'm saving that right now. And I put everything that I need to remember into a Google Keep file until the end of the stream, and then I try to address it all. So I'm not just reading your stuff off and forgetting about it. Cool. All good to go. All right, let's go. All right, so just gonna give a couple more minutes. Like I said, get comfortable, kick your shoes off, relax, sit back. It'll be chill. Again, the concepts tonight are going to be a little heavy. If you've never coded before, these concepts are going to be heavy, and that's okay. Don't sweat it. The concepts we'll be going over again in the Python Bootcamp. But we're just going to be learning how to do this stuff with Go, and we're going to solve some problems, and it's going to be fun, and we're going to have a good time doing it. So it's going to be jam-packed. So let's maybe we'll get set up first. We already got our slides up. Oh yeah, the Gophers right here. Cool. Let's actually look at what do we have for next week. So this is the last one for this week. Oh, we're straight into Linux next week. So we have 3 parts of Linux, which is exciting. That's gonna be exciting. So if anyone has been trying to anyone likes my setup and wants to more easily be able to follow along exactly with what I'm doing, same commands, same things like that. Next week, once we go ahead and get Linux installed, you'll be able to follow along exactly as I'm doing now. You'll be able to mess with that. So that'll be pretty fun. 3 parts of Linux. We got a Linux lab day. That'll be fun. We'll do some bash scripting, get some automation in there. Man, I always forget about this. I remember the first time I made this, the syllabus, I was like, ooh, this is a lot. One of the biggest things I'm worried about this time is, and I think I split it up this time. I did. I replaced something else with a second container orchestration piece because Kubernetes is going to need 2. I really want to introduce people to Kubernetes because Kubernetes is so big right now, but it'll take up 2 classes this time, which is great. Cool. Got a lot of stuff. All right, let's get started for time's sake so we can get into some problems. Gonna try to get into, I want to make sure tonight, because the concepts are so heavy. Again, the goal is always 2 hours. Last night, we actually made it 2 hours. Last night, we got off at like 10:10, which was great. Tonight, we'll probably get through the core concepts right around 9:20-ish, and we'll get to some practice problems. But after that, you should be able to drop off once we get to the practice problems. Stick on as long as you can, but I'll make sure all the information is out there before 10, and after that, we'll just be some practice problems. All right, let's close this up. Music's good, sounds good. Let's see, can we use Linux and VirtualBox for this course? Absolutely. I actually did this whole thing in VirtualBox last time. The only reason I'm not doing it this time is we learned a little bit about uploading and downloading files during a stream can cause some issues. So, once you've been taught a lesson, go ahead and do your best to change that thing. So this time we are streaming through a laptop that's streaming through another PC. So do a little dual PC setup here, but you can absolutely use a VirtualBox for this. We'll actually be setting up virtual machines next class. So on Sunday, we'll be setting up virtual machines. But let's hop into it. Programming with Golang Part 2. Ready, set, Golang. So let's do a recap of what we learned. Take it slow. So last time we learned how to get Golang installed. We took our time. We did our best to get Golang installed. So hopefully you were able to get that installed. If you weren't able to get that installed, you have the Go Playground available to you. If you're new to the stream, you have the Go Playground available to you. King Juice, I've been live but just about 10 minutes. I really need to get that uptime command in there. But yeah, so we got Golang installed again. You can use the Go Playground if you do not have Go installed, so no big deal there. We cover VS Code, we cover Visual Studio Code. Yesterday was actually very funny because the Python course is the introduction to coding, just using Python course. I'm trying to use VS Code and I haven't really used it in a little while. So I had a lot of trouble just going through my settings and stuff. And it's amazing how something that people think is so intimidating like Vim, as a Vim user, when I got into VS Code and people wanted me to change my settings and find certain things, man, I was lost. But maybe we'll use VS Code for some of the stuff, but I'm probably going to be using Vim for most of tonight. We talked about displaying output. So again, we use that FMT, that format.print, that FUMPT.print function to be able to print stuff to the screen. We learned about different ways to print. So print line, which gives us a new line character at the end. Print, which is prints which you pass to it. And we talked about printf, which allows you to format your printing. We talked about variables, which are the placeholders for those values. Variable being something that can change. We talked about data types, things like your strings, think double quotes, words and those are words and phrases. We talked about integers, which are whole numbers. We talked about floats, which are decimals. We talked about booleans, which are true, false values. We talked about tons of stuff there. And we talked about math operators. We talked about how you could add, you could subtract, you could multiply, you could divide, and you could also do things like increment by 1 and decrement by 1. And you could use an operator called modulo or modulus, which is division, but it returns the remainder instead of the divided value. So that's our quick recap on what we learned last time. It was a lot. If you weren't around for that and you don't know anything about what we're talking about, definitely go back and watch those. Those should still be up on Twitch and up on YouTube pretty soon. So we're gonna hop straight into it. First thing we're gonna do, we're in the part of the course that now we're into the logic. So we learned a little bit about the tools, but we haven't done any logic yet. And this is where programming gets cool. So logic, we're gonna smack you in the face early with comparison operators. There's a lot on the screen. Don't worry about that. We're about to hop straight into some Go files, and we're gonna go ahead and see what these things mean. First things first, equality operator. So these are just, so what is a comparison operator? First, let's talk about that first. Comparison operators are operators that compare two values. So basically, you have these operations right here. There's a bunch of them. And you can compare what's on the left, and you can compare that value or that thing to what's on the right. And most programming languages, all programming languages have something like this. Most of them, they are something similar to this. Some things have 3 equals for strict comparisons. Some things have different symbols and things that they use to represent these, but these are generally across the board in every programming language that you're going to use. And so the first one we're going to talk about is equality operation. So this is an operation that compares 2 items and sees if they're equal or not. So it compares what's on the left to whatever's on the right, and it returns whether or not they are equal. So one thing to write down. We're definitely going to talk about or and and later. I see that. We're definitely going to talk about or and and, so that you can add more than 2 things, but it's still really 2 things. But comparison operators always return. Now we're going to use the words again. We're going to use the words that we know. They're always going to return Boolean values. What are Boolean values? That's a data type that is true or false. So every single one of these comparison operators, they're going to return a value so when you compare 2 things, it's either going to be true or it's going to be false. Those are the only 2 things that can come out of it. Yes, technically they're not comparing values for the and the or, but yeah, we will add them in here because we'll chain some of them together with the and or use them to decide functionally what to do. But yeah, so they always return a true or false. So you can see over here, I just have true and I have false values. So equality, this is checking if 2 things are equal. Here's my thing here. It says 5 is basically this operator is asking, is 5 the integer 5? So remember, you don't see any quotes here. Is the integer 5 equal to the integer 5? Yes, it is. So that will return a true value here. And then we have over here us trying it again, and we're saying basically, is the number 5, is the integer 5 equal to the integer 6? And we know that is not true, so that returns a false value. And so let's hop in straight into some code, just so you can see it real time. So I'm gonna go into our Go DevOps thing here. Let's make a folder called comparison, and we're gonna go into comparison, and we are going to create a new file called equality. Equality, that's not how you spell equality. .go. All right, and so set this up for me. So Go automatically set this up for me. And actually, I'm gonna make this text a little bigger in a second. I'm gonna go out after this one and make my text a little bigger. So we're gonna keep this print line here, and we're gonna say, is 5 equal to 5? And then we'll go ahead and we will let's copy this, and let's say we're gonna do exactly the things that that I put in there. So the first line is going to print out whether or not 5 is equal to 5. The second one is going to print out if 5 is equal to 6. And we're going to go run equality.go. And you can see here, the first one returns true because 5 is equal to 5. And the second one is false because 5 is not equal to 6. So very simple there. The equality operator is one that's generally very simple to understand. Just checking if what is on the left is equal to the one on the right. Now, does that mean you can only do integers? Because I use numbers here. Let's say, what if I made this a string here? What do you think that would be? And let's comment this out so it's not a bunch of output. Is 5 equal 5 integer, the type int? If I highlight it, will it give me anything? No. Is 5 int equal to string 5? Let's find out. The world may never know. All right, so it's actually telling me that I can't compare these two things. They're mismatched. I can't compare these two things here. Again, this is because this is a strictly typed or strongly typed language. Other languages, you can do something like this here, but there are ways to do this as well. But you can see that they are not equal, but it won't even allow us to do that. So we'll leave this file as is at 5 equals 5 because we're going to push this file up with Git later on because we're going to learn a little bit about Git. So what's the next one we're going to learn? Let's go to the next one, inequality. So we're going to go to copy equality to inequality.go. All right, so now we're going to check inequality. So this is the inverse of what the equality operator checks for. So instead of checking if two things are equal, this is going to check if they're not equal. So if this is the inverse, then the output is going to be the inverse. So whereas if it checks two things are equal, it returns true. If it's checking for inequality, if it checks if 5 is not equal to 5. So whenever you see this exclamation point or bang or whatever you want to call it, that's kind of the switching. It's making it a not. So it's basically, is 5 not equal to 5? And that's false because 5 and 5 are equal. I know this can be a little bit confusing. I've heard a lot of thoughts about whether or not you should ever actually use inequality operations. You should. I mean, I found situations to use them, but a lot of people there's again, because these are inverse. There are ways you can leverage either one of them for what you're doing. But 5 is equal to 5, so therefore it's not unequal. So this is a false statement because again, it's checking whether or not the thing on the left is not equal to the thing on the right. So that's false. But is 5 not equal to 6? Correct. 5 is not equal to 6. So this is a true statement. This is a very true statement. And so that's what inequality operators are. And so we can take this and we can go back to we can vim our inequality.go and we can switch this up here. And we can say, is 5 not equal to 5? And 5 not equal to 6. And we should get false. And then we should get true. And then we got false, and then we got true. So the inequality operator could be a little bit confusing, again, just because it's the inverse of the equality one. And sometimes when you're doing the inverse of something that only returns a true or false, it's like, oh, is that true? Is that false? So it can be a little bit confusing. But just, again, the concept that it's important is that you can compare if things are equal, and you can also compare if they're not equal, because that's important. And then we'll do both of these in the same file. So greater than and less than. So is what is on the left greater than what is on the right? If so, it will return true. So is 5 greater than 4? True. Is 5 greater than 6? 5 is not greater than 6. Therefore, it is false. And again, less than is, it's not really the inverse of greater than less than, but yeah, it's so we're checking if what's on the left now is less than what's on the right. So is 5 less than 4? This is false because 5 is greater than 4. And so again, these can always get a little confusing. I find that people struggle with less than. I find that people struggle with inequality. So again, you just want to make sure this statement, you want to just check the statement, read it straight through left to right. and see if in your head, when you say it out loud, if it makes sense. So is 5 less than 4? No, it's not. No equals false. Is 5 less than 6? 5 is less than 6. Therefore, it's true. And that is how you would do those two things. So again, we'll create a new file and we'll throw some different numbers in there. So let's do let's copy again. But let's call it, what do we want to call this? We want to call this greater, less. A dumb name, but it's all good. So we're going to say is 2,000 less than, let's do greater than first. Is 2,000 greater than 5? Let's leave 5 in there. Is 2,000 greater than 5? Absolutely, yes it is. So we can just type a comment in here and we can say should return true. Remember, if you haven't seen what comments are just bits of text that the interpreter or compiler will ignore. So in Go, the way that you do comments is this double slash right here, and you can see how it changes colors. Basically, you can use these to document what you're doing, make notes. There are a lot of reasons for comments to basically temporarily remove code for a little while. But I'm just gonna put a little note there so that we know that this line should return true because 2,000 is greater than 5. And we'll do the same thing here. Is 2,000 less than 5? And we know that this one should return false because this is simply the same statement, well, the inverse of the statement. So should return false. And I'm struggling. Okay. And we'll run this. Take a look at it again. First one, it should return true because 2,000 is greater than 5. And then it should return false because 2,000 is not less than 5. Get out of here. And we'll do go run. Run. Not rum. Run. There we go. We got true and then we got false. So greater than less than. Is what's on the left greater than what's on the right? Yes or no? Is what's on the left less than what's on the right? Yes or no? And then we have greater than or equal to and less than or equal to. So we're gonna hop back into that same file really quick, but greater than or equal to now adds a second, it's almost a second comparison here. So we have greater than, and we all have the equality up here. So it says, hey, is what's on the left greater than or equal to? So now if 5 greater than 5, so 5 greater than 5 would actually return false because 5 is not greater than 5. They're equal, so it can't be greater than. But is 5 greater than or equal to 5? Absolutely, because it is equal to 5. So that's true. So if you ever need to, there's a lot of times where there's some confusion with this versus this. This will often, the use of this or not the use of this will often result in an off by 1 error. You're gonna definitely run into an off by 1 error tonight. I'll show you guys, we're gonna be doing some loops and stuff, and we'll show you why you would wanna use this comparison operator here. So is 5 greater than or equal to 4? Yes, it is greater than 4. It's not equal to 4, but it is greater than, and this is an or here. It's greater than or equal to, so only one of these have to be true. Only one of them is, as long as one of them is true, the whole thing returns true. So yeah, so as long as one of them returns true, the whole thing returns true. And again, less than or equal to does the same thing. So 5 is greater than or equal to 5, but 5 is also less than or equal to 5. Again, because the equal is where this becomes true, and it only has to match 1 to be true. Is 5 less than or equal to 6? This is also true because 5 is less than 6, but it's not equal to 6. So I actually don't think we need to dive into that. Take a second, look at this, take a screenshot of it, write it down if you need to write it down, and then we'll move on to the next piece. What's next? To loops. So loops is where it's gonna get real weird. Well, not weird, but we might have to stop a little bit and go through it a few times, no pun intended, for loops. So just take a look, ask any questions that you have about comparison operators, how they work. If you want to see a specific case, let me know. We can type out specific cases and see how those things work. But again, you can compare one thing I didn't show you is you can compare things other than numbers. I only did numbers here, but you can, for things like strings, you can compare whether or not they're equal. A lot of the times for greater than and less than, you're gonna have to make those things integers, but I can say, is this equal to that? And I'm gonna go ahead and comment this out. And I'm gonna go run this, and this is not equal to that. Yes, this is not equal to that because they are two different strings. But obviously, if I make the strings the same, then it's gonna give me true. So you can check against things like that. You can check against, it's not only integers, but yes, you can use these comparison operators to compare other things as well. So that is that. All right, if you have an inequality comparison in the same line joined by and or, you can use De Morgan's law to invert it, but honestly, it sounds like much more work than it's worth. Yes, that's, I don't know what that law is. I'll look it up. Let me put that in my Google Keep as well. I like that. I like to learn new things that I can refer to later. But yeah, using kind of the inverse, the inequality, and equality things, like it's you can flip them around and mix them up and do all kinds of things. Also, someone brought it up. Let's throw it in here real quick because we will have to use it later. I'm obviously gonna. I have to teach you. This would not be a boot camp if you didn't learn how to do a FizzBuzz type problem. And so we're gonna need this and or operator to be able to do that a little bit later. So you can combine these comparison operators. You can combine them to it still will result in a true or false value, but you can combine them multiple ones together to do different numbers of comparisons to be able to return a true or false statement. So how do you do something like that? And let's say we wanted to know them and or .go. This one didn't give me anything. Import pumped, and let's go func main open close open. Let's close it first. All right, so I could say something like print. This is not Python, so I cannot say something like print. I can say, whoa, wow. I think, is my shift not working or did I? Oh, okay, there we go. I can say something like, we want to check. Let's put a comment here. We want to check if 5 is greater than, we're going to use a variable because we learned about variables. We're going to set a number. We're going to say check if 5 is greater than num, or if num is equal to 10. Now that's super random. This is super random, but we have two things that we have to check for here. So for some reason you may have to do this, but basically let's set up a variable really quick called number, or called num. So num, what are we gonna set it to? Let's go ahead and set it to, first let's set it to 13. All right, so number is 13. And we wanna write, we wanna basically check if 5 is greater than num. So 5, this will insert 5. Is 5 greater than num? So let's start with that. Let's get the first part right. Is 5 greater than num? Check. Go run and or .go. False. Why is that false? Think about it for a second. It is false because what is our num? Our num is 13. Is 5 greater than 13? Absolutely not. Therefore, that's false. All right, so now let's solve the second piece of this. And maybe we can do it this way. And We'll put it on a different line, and we'll say is num. We want to check if num is equal to 10. I actually put double equals there out of habit. So is num equal to 10? Let's see. Is num equal to 10? Num is 13. Is that equal to 10? It is not. So we should expect a false there. So we should expect 2 falses to print out. So we're gonna run this and we get false, false, which is great. But how could I combine that into one line? So let's combine that into one line to check if both of these things are true or if one of these things are true. So we did an or. What is the difference between and or? And means both things need to be true, or means only one of the things needs to be true. So adding in this, adding in the and or the or, still this statement still only returns a Boolean value. It doesn't return 2 things. It returns a single thing, and that is a Boolean value. So if I use an or operator looks like this. It's 2 pipes. You call these pipes. It's the key that's above your enter key. If you use those, that says or. So that says if this comparison over on the left is true, or if this one on the right is true, then the whole thing is true. Only one of them has to be true, then the whole thing is true. They're both false, then it is false. So is this going to be true or false? Is 5 greater than num? No, it's not. 5 is not greater than num. So this is false over here. Is num equal to 10? Is 13? It's not. So this will return false. So let's check this out. And you'll see that we don't get 2 outputs. We get a single output and we get false here. Now, how do we get, so let's check out an and now. So let's say this said and an and is actually 2 ampersands. So an and looks like this. So that means what's on the left has to be true, and what's on the right has to be true as well. We already know both of these are false, so this will also return false, but I'll show you, we'll go ahead and we'll make it true in a second. So let's make this true. Actually, let's go ahead and make the other one, let's make the or true first. So let's go back to or. So this is, again, this is an or statement. And to make this true, let's make only one of these true. So 5 greater than num and num equals 10. So let's set number equal to 10. So now the number is equal to 10. 5, is 5 greater than 10? No, it's not. So this is still false. But is 10 equal to 10? Yes, it is. So this is true. So now, even though one of these is false, the whole statement still evaluates to true because this is an or statement right here. And let's see that just to make sure we are correct. And now this evaluates to true simply because one of the statements is true. And again, you wouldn't only need 2. If you needed more, you could do another or if you'd like. And again, in that or statement, only one would need to be true for the whole statement to be true. But for and, the only way we could make this work as is, we would have to make this is 5 less than num. And so both of these are true. Both of these should be true now. And so if I do an and, both of these have to be true for it to work. So we'll change it in a second. But this is, we already saw it fail once. But this side is true. So 5 is less than 10 and 10 is equal to 10. So this whole statement will now return true. Excellent. So now we know how to compare stuff in Go. We learned about the comparison operators and we learned about and or. Again, take it in. You'll be using these a lot to make decisions in your applications. You'll be using some other things that we're about to show you in a little bit. And actually, you know what? I'm gonna move this above loops. We're not gonna do loops next. We're gonna do if statements. So we did comparison operators, but I think this is perfect to go into if statements after this. Are double pipes or? Yes, double pipes is or. Should do a short circuit case. What's a short circuit case? I'm not sure what that is. Type is shift backslash a backslash on most keyboards. Yes. Thank you for that. Is that using ternary operator short circuit? Yes, it's a good question. That's what I'm wondering as well. Crossing a ternary operator use. Completely confused. Still sort of am. Yes. So ternary operators are only going to make sense after we go over this next part, which is if statements. But yes, condition, if true, do this. Yes. Okay. So yeah. So we can do if that's a short circuit case. Yes, I could show you how to do something like that. I actually don't know if Go has ternaries, to be 100% honest, but if it does, we'll find it really quick. But either way, a ternary wouldn't make sense until you knew if or else's really quick. Can you give me the slide to download Golang? I think you can just, depending on your operating system, you can do like Go Mac, and it'll give you the link, or Go Linux. Or if you don't want to download it right now, or Go Windows if you have Windows, and it'll give you the link. Or you can go to the, play.golang.org if you need to. So here we go. Go Windows. There you go. Oh, you already did it. Yeah, there we go. Or you can go to that Go Playground. It looks like AutoExec just posted the link to the Go Playground. But if you want to install it on Windows, it has an easy installer. That link that I just gave you should take you there, and you should be able to get it installed. But cool. Next thing we're going to learn, again, we're making decisions now in our application. What are we going to do? We are going to use if statements, if and else's, and else ifs and else's. So ifs are very simple. These are also, these use comparison operators, or it's not always just a comparison operators, but commonly use these comparison operators that we just learned. I actually don't know why I put this GIF here. This seems irrelevant, but cool, doesn't matter. If statements, it says if something is true, then do this, then run this piece of code after it. So if this is true, go ahead and run this code. If not, do not run this code. So very simple thing. Very simple concept. Again, plain English. This is also a thing across the board in programming languages. So this is not exclusive to Golang, but it says if something is true, do something else. So let's look at that first in real time. So Vim, let's make another file, if.go. All right. So what we're going to do is we are going to import FMT, and we are going to, why did it set up? I wonder why it set up the first one for me and not the rest of these. All good. Oh no. Whoops. I'm struggling. All right. Here we go. So we are doing, what are we doing? I forgot that. If. Okay, so let's say my name is, actually, let's say my age. Age, let's use a number. So I'm 29. So basically, actually, let's say age is 29. And maybe we want to write an application to say, check. Maybe we work at the club and we want to say, check if a person is old enough to drink. All right, so we can use an if statement to determine whether or not my age is old enough to drink. So we can basically say if the way you use if is to just type if, and this starts an if statement, and then you type the comparison that needs to happen, or you need to type the thing that there's basically a statement that it needs to check to be true. So in the United States, the legal drinking age is 21. So you say if age, the thing that we want to check is if our age is higher than 21. It's 21 or older. So if age is greater than or equal to 21, then do something else. So it's going to look like this. It's going to say if age is greater than or equal to 21, then run the code below. So again, this statement has to evaluate to true. So it's going to check this thing. It's going to evaluate to true, and then it's going to run some stuff after it. So actually, I think this needs to go in. Actually, don't. Let's see. It's going to go on some quotes here. I mean, some. This is where, again, going back and forth between languages, syntax, I get confused sometimes. I think you need those. I think. And then I'll say, if it is, go ahead and print format dot print line you may enter the bar because you can drink. If a bouncer ever says this to you, or someone at the door ever says this to you, you should leave, because this is a very weird way to tell someone that they can get into the bar. And then we'll go here, we'll close this out. Cool. So basically, again, like I said, it's going to check if this statement is true. And I don't know if those, don't write this down yet, because I don't know if those, I don't know if the parentheses are supposed to be there or not. Again, I'm actually having a lot of trouble moving in between languages syntactically right now, which would be a good thing for VS Code. VS Code would probably fill that in for me. But if this is true, then do this. If it is not true, it won't do. Our application as it's written now, it just won't do this thing. Like, it'll just keep moving on past this. So let's go ahead and save it. And we're gonna go run if.go, and it's gonna run. So maybe I do, maybe I don't need those. I don't know. Looks like, oh, someone says you do not. Oh, right, this is go. Yeah, it's exactly going back and forth. It's like super confusing. So it did work. We wrote it properly, and because my age is greater than 21, so it says you may enter the bar because you can drink, which again is a dumb thing to say as a bouncer. Now, what if I was only 20? Let's say I'm 20. So basically, the flow of this code goes. Age, let's use the words that we've been learning to describe what's happening here. We declared a variable called age, and we gave it the value of 20 It's supposed to represent 20 years old, but we gave it the value 20, which is an integer. We gave it a value of the int 20. Then it goes down here and it says, hey, if the value of age, which we know is 20, if that is greater than or equal to 21. So if this returns true, if age is greater than or equal to 21, go ahead and print this, and then nothing else. So if age is age greater than or equal to 21? No, it is not. It is less than 21. It is not equal to 21. It is not greater than 21. So this is false. So this code right here should not run. So let's go ahead and run it and make sure it runs. So we ran the code ran successfully, didn't give us an error, but we got no output. And therefore, it didn't print anything out. When I ran it this time, it just kind of kicked us right back out. The code actually did run, it did evaluate, but because we didn't tell it to do anything, it did not do anything, which is great. So that's all an if statement is. It says, if this statement is true, do whatever's in between these curly braces, it'll go ahead and it'll run. So as much code as I have in here, it will run that code here. So what are the other two things that we had on here? Say else if. So else if allows you to run in the same comparison statement, or after it evaluates the if, it gives you another chance to run a comparison statement. And so you can have as many of these as you like, but it'll go through and it'll run the if first, and then it'll drop down and it'll check the next one. So else if allows you to say, else if this is true, do this. Else if this is true, do this. Else if this is true, do this. So it allows you to check more things. So let's say yes, we're at the bar, but let's say we're gonna do else. The way you do else if first is what's happening here? I think you just do else if and things like this. Again, I'm trying to remember what the syntax is in Go. This seems right. It's different in every language, but I could say here else if I do an else if, I have to give it another thing to compare. So I can say else if age is, let's say, yeah, you can get in if you're older than 21 because you can drink. But let's also say if you are, no, that won't work. Let's say, but if you are less than, else if age equals 21. Let's go else if age equals 21. You can do 18 and 21. Yes, I'm trying to think of, so my problem is I'm trying to think of something to where I can easily add an else statement at the end when we get to else in a second. But let's just do something stupid, right? We're doing something stupid right now and say else if age equals 21. We're gonna say let's do greater than 21. This is really dumb. Equal to 21. You may enter the bar because you are the exact. No, we're gonna have the person say something stupid. 21. He's gonna say blackjack. This is so stupid, but yes. And so actually, right here, we're actually gonna change this to 20. No, we're not, because we're gonna get the same thing. This is dumb. Yeah, he's gonna say you can enter the bar because you can drink, but if you're exactly 21, he's gonna say blackjack, which is stupid. And again, that's not a bar you should go to. And maybe I'll read your, I'll read the chat in a second. I'm sure you guys have given me some good ideas, which we can do. Let's see. So I don't know if else if is this way or if it is. All right. So if our age is 20, we still haven't told it to do anything. There's no cases that match this. So our age is not greater than 21. So it shouldn't print this. And our age is not 21. So it shouldn't print this. So we should get nothing again. Oh, whoops. Age equals 21. Oh, I don't need these. Maybe I don't need these. And else if might be something like an underscore. I might have to go by example really quick. Is it else if? Is it elif? No, it's else if. Let's see. It's else if, so that seems right. Let's go by example really quick. So this is how I reference things. I just do go by example. Wow. Oh, quote on blackjack. Oh, thank you. Yep, that'll do it. I was like, this seems weird. So it shouldn't print anything because we told it basically none of the cases are right. So this has to be true for to do this block of code, or this has to be true for to do this block of code. So let's go ahead and make it 21. And we know 21 is something that it should respond to. Escape. Blackjack. Our doorman is weird and he shouts blackjack whenever someone who comes is 21. And if you're over 21, he just lets you know that you can get in. Well, actually, let's let them know they can still enter even if they're 21. You may enter the bar. All right. Now, we can add in more else if statements if there was more cases that we want to do. But a lot of times you want to have a, not a lot of times, but sometimes you want to have a default case. So like, yeah, we know that if you're over 21, you can get into the bar. If you know you're 21 and over, you can get into the bar. And we've handled that with both of these cases. But what about everyone under 21? So as the bouncer, we want to give these people who are under 21, we want to tell them that they can't get into the bar, but we don't want to have to make an else if case for every age. We don't have to say, else if you're 19, you're only 19, you can't come in. We don't want to say, if you're 18, hey, you can't come into the bar. We don't want to make a case for all of those things. The else here allows us to basically be a catch-all. It says, if something is true, do this. Else, if something else is true, do this. Else, do this. So nothing has to be true. As long as none of the statements above it are true, then this else statement will run. So we're gonna go ahead and add in an else here. We're gonna say else, and you don't need any operation, or you don't need any comparison operator here. And you can say else format.print line you shall not pass. How about that one? You shall not pass. Exclamation point, because we all like a little bit of Lord of the Rings there. So what this will basically do is check if you're over 21 or if you're equal to 21. So if you're not one of those two things, obviously you can't enter the bar, and it'll let us know that we can't pass. And if we go to 20 years old, not 210 years old, and we run this, it runs through those comparisons and it says you shall not pass. So again, it does go in order. If statements do go in order, and it checks this first. It says if this case matches and is true, I'll go ahead and I'll do this. And it is important to note that after it does that, it will not go and try anything else. So the first case that it matches, it will go ahead and it'll run that code, and it will drop out of this. So Again, that's super important to remember, because it starts to matter how you align things, the order in which you put things, as well. So it goes through, it says, hey, age is not greater than 21, 20 is not greater than 20. So let's go down one. And it's going to say, else if age is equal to 21, 20 is not equal to 21. It says, cool, we're not going to run this code. Let's drop down. Else says, run this no matter, as long as these cases above me don't match, go ahead and run me. So else is like your default case, your catch-all case. It's not, you don't have to have one. You saw before we ran this and we didn't have one, nothing happened. But if you add one, you can add a default case that kind of takes over there. So take that in a little bit. If statements, very simple. Well, the concept of what they are is very simple. So again, if something is true, do some instructions that I gave to you. Else, if something else is true, do some code that I gave you. Else, do some code that I gave you. If none of the things above this equal true, go ahead and run some code that I gave you. All right, so those two things in themselves are actually very powerful, and you can use them. We wrote an app. We just wrote an app to be able to check someone's age and to determine whether or not they can get into the club, and give them snarky answers based on either if they are or not, or if they're 21. So you could have unlimited else's. You can only have one else. It is important to know you can only have a single else, because again, it's the default, it's the catch-all. You can have as many else ifs if you want, as you want. You could also just have a bunch of if statements, but that there are situations where that is more agreeable depending on what you're doing. So I could say if age is greater than 21, run this bit of code. Then I could say I'll just do it. But every time you start an if, it's a whole new statement. It's a whole new block. And then I could say, if I did a whole new if here, I'd have to give this some comparison operator. So I'd say if age is less than 21, then do this. So you can do something like this. Not really. It's dumb. Really dumb. Really dumb here. So looks like someone asked, can you use and instead of an else if? So that is a really good question. So you cannot use an and in place of an else if, because in adding an and, so you can add ands to this statement, but you got to think an and checks and compares if multiple comparison operators are true. They both need to be true for something to happen. If you use an else if, that means that the first one wasn't true. So the only way you're going to get down to an else if is if the first statement was not true. So you can't really take the place of that. But what you can do is I can do something like this. I can combine these two statements right here, and I can combine them, and I can say if age is greater than 21, and this is dumb because there's an operator for this, but I can say and no, that would be dumb because that would fail. But you could combine two things. Like I say, if age is greater than 21, actually let's do another if. We can say multiple of them will print, but I can say if age is greater than, well, that's a dumb statement. Between 18 and 21. So let's say if age is, that's good. I could say you can go drink in Canada or something, is less than or is greater than or equal to 18, and age is less than 21. So if you're between 18 and 21, then full format dot print line can't drink here, comma, but you can go to Canada. And it's actually a pretty interesting exercise because I translated all these to if statements. Then I didn't know that. 18 in Quebec, 19 in Ontario. That's pretty interesting. But because I did this, What's happening here? Watch what happens. Watch the difference between doing multiple ifs and then doing a bunch of else ifs. So I'm going to go ahead and run this, and I'm going to run this within. I'll leave it at 20. So what do you think? What do we think this is going to do this time? Now that it's all in ifs instead of else ifs, what's it going to do? Let's run it, and then we'll walk through it. So age is 20. It went through and it printed out 2 things instead of 1 thing. So it says can't drink here, but you can go to Canada. And it also says you shall not pass. So let's take a look at what that means. So age 20, again, ran through. It's check this. It says if age is greater than 21, go ahead and print this. Age is 20, so it's not. So this is false, so it drops through and it does not run this code. Goes to the next thing. It says if age is equal to 21, print this. 20 is not equal to 21. It doesn't print any of this. We didn't see blackjack. You may enter the bar. Drops down to here. It says if age is greater than or equal to 18 and age is less than 21, then go ahead and do this. And so 20 is greater than or equal to 18, but it's also less than 21. So it did print out can't drink here, but you can go to Canada. If we had done if else's, when it got to this statement, once it matched here, it would be done. Remember I just said that once it finds a match, it's done. But because we initiated another if statement, it's going to run each of these comparisons every time. So it's not going to drop out of this comparison. These aren't all together. It drops through, and now it compares this one. It says if age is less than 21, go ahead and print this. So 20 is less than 21, and it prints you shall not pass as well. So if you do a bunch of if statements, it's going to evaluate all of them no matter what. It's not going to stop. It's not going to stop once it finds a match. So if you're trying to solve a problem where you just need it to match one case, then you would use your else ifs. If not, if you want to check against a bunch of things, you could do a bunch of if statements. Yeah, just want to throw it out there. I've seen people ask that before, so you can do that. But a new if statement, you can only have one if statement per block. Again, every new if statement creates a new comparison grouping. And then you can have as many else ifs as you want. You can have a million else ifs if you like. Shouldn't do it, but you could. And then you can only have one else. So one if, one else, as many else ifs as you'd like in between, which is interesting. Let's go back. If something is true, do this. Else if something else is true, do this. Else, if neither one of these, if none of these things above me equal true, then do this. So that is all if statements are, and they're pretty cool. They're definitely pretty cool. Can you use an or instead of else if? Yes, you can use an or instead of else if. We talked about how you could use an and instead of else if, but you could use an or instead of else if. But the problem is, yes, you could use an or. You could use an or instead of else if. Perfect thing right there. So in place of an else if, you could use an or you could use an else if you felt better. Age is greater than 65, drink milk. That's definitely what we should check for. If you are older than 65, you also cannot come into the bar, or you shouldn't be at the bar unless it is a 60 and over bar, which are the best bars. But you should be drinking milk. Got to get your bones right. Osteoporosis is the thing for sure. Go have a Tim Hortons. So it's very interesting. I never had a Tim Hortons because I'm here in the US. We don't have Tim Hortons here, but I watch 2-car YouTubers called it's the Straight Pipes with Jacob and Yuri, and they're always checking if the Tim Hortons cups fit into the cup holders. Or maybe it's not Tim Hortons, maybe it's something else. But I think it's Tim Hortons cups, and I want to go to a Tim Hortons just because now I'm familiar with them. One day I'll get to Canada. I've been to Canada once, I think. I took a cruise that ended up in like St. John's or something. But yeah, I definitely need to get to like Toronto or something. The and or the only part of evaluation after an if or else if statement. It can't be used in place of if. Oh yeah, or else if. That is true. It can't be. Cool. There is no point. DevOps schedule. Don't buy a car without Timmy's holders. Absolutely, I agree. I mean, I don't have a Tim Hortons here, and I would not buy a car without them. But cool. All right, now we're gonna get into the real fun stuff. And so this is where For loops, we're gonna get into loops. We are going to, I want you to focus on I always say focus on the concepts, but the syntax of a loop, especially a for loop, will really throw you off. If you're trying to memorize the syntax and you're focusing on that, don't focus on the syntax of a loop. Focus on, and syntax, if anyone doesn't know what syntax is, that's the structure, that's the, needing a semicolon, needing parentheses. It's the structure of what we're setting up. Focus on the concept of what a loop is. Loops are very powerful, and loops are how you'll solve lots of problems. You use loops all the time. So what is a loop? Very simply, a loop is used to run a set of instructions multiple times. So if you write a piece of code and you want to evaluate it multiple times, a loop is how you do that, so that you do not have to keep, writing a new if statement or writing a new, thing, a new comparison or a new something else. It allows you to run things multiple times, over and over again. And that's why you see the car just going over and over again. There are different types of loops. There's a for loop, there's a while loop, there are do loops. There's all kinds of loops in different programming language, but Go only has for loops. That's all they give you. Again, Go's kind of focused on simplicity. Go only has for loops. And the first time when I first heard this, I was like, this is ridiculous. Like, I hate, coming from Python before Go, while loops are great. I love while loops. That was my go-to. But for loops are really all you need. There's different ways to go through for loops. We're going to go through the hardest way to do a for loop. We're not the hardest way, the hardest syntactically, because you can use it in every case, but there's some other ways to use for loops in the way that we're going to use it, which is interesting. But yes, Go only has for loops. And loops run basically a loop will run for as long as the scenario you specify is true. So as soon as you hear me say that, as soon as you hear me say loops run for as long as a scenario that we specify is true, you should automatically be thinking, one, that's a Boolean. Two, we know that comparison operators only return Booleans. It only returns a Boolean value. So for a loop to be able to work the same way that we did in if statements and else ifs, we're probably going to need to create some type of comparison operator to be able to evaluate these things. So as long as something is true, as long as your comparison operator is true, the code will run. So that is how a loop works. Runs code over and over again. It loops through code, basically runs it multiple times, and it'll run for as long as a scenario that you create is true. And so that may be easier to, I found loops to be a lot easier when someone showed me a loop. So we're going to hop into a loop. So the first thing we're going to do is we're going to count to 100. We're gonna write this. We're gonna write this code really quick, and I'm gonna write it shorter. Actually, I'll do it just like that, so it makes a little bit of sense. So this is gonna be what happens in the first run of our loop. So basically, we're gonna use a loop to count to 100. What are the ways that you can count to 100? We could print out 0 to 100. So we could write format.println 1, format.println 2, format.println 3, format.println 4. But that's inefficient. That's not really what you want to do. There are faster and better ways to count to 100. Python has cool things like range. Unfortunately, Go does not have something like that, or at least not that I know of. Whoops. So the first run, let's talk about what happens during a loop. A lot of words here. Again, we'll see it practically. I just want to talk you through the run of a loop. So let's set it up. Our starting number is 0. So the goal is to count from 0 to 100. Our starting number is 0. Run basically the way the loop works. Again, we're going to try to put a loop into plain English. It says our starting number is 0. Run the following instructions for as long as our starting number is less than 100. So we want to run this for as long as our starting number is less than 100. After you complete running the instructions that I give you, add 1 to the starting number, then start over again. Now, that might be confusing. Let's look at the code right here and let's compare it to what we have over here. So we said our starting number is 0. Here's a for loop. So ignore all, you've seen all this as to be the main Go setup. But we're gonna write this in our code really quick. But for. So for is how you start a for loop. The same way we're going to do if. We just type out for. We type out for, and we're going to say our starting number is 0. So the concept of saying our starting number is 0 is basically declaring and adding a value to a variable and assigning a value to a variable. So starting number is going to be our variable, and our starting number is going to get the value of 0. So for the first thing we're going to set up is starting number equals 0. So you've seen this before. You've seen a variable, and this is the shorthand to declare it and to assign a value to it. We're going to set that to 0. So that's the first piece of a for loop. You set up this variable here, this counter here, over here, or you can use it for a number of things, but usually there's a counter. And then it says run the following set of instructions for as long as our starting number is less than 100. So we know how to check. We just learned some comparison operators. We know how to check if our starting number is less than 100. How do you do that? You check if starting number is less than the less than symbol, the number 100. And so in a for loop, that's going to be the second thing. So you see this semicolon here. So there are semicolons. Someone asked about semicolons. There are semicolons in for loops. I forgot about these. But this is going to be the statement that we need to evaluate. The middle statement. There are 3 statements here. There's 1, there's 2, there's 3. The middle one is going to be the one that determines whether or not the loop runs. So as long as this statement evaluates to true, then our loop will run. So is starting number less than 100? We see that starting number is actually 0. So starting number is less than or equal to 100. So our loop is going to run. This statement evaluates to true. Our loop's going to go ahead and run. What's it going to run? It's going to run this code that's down here. So just like our if statement, it's going to run this code that we put in between the curly braces, which is format.println starting number. And so we know starting number is this right here. So it's going to run and it's going to print out 0. So the first time this runs, it'll print out 0. And then we see this thing on the end here. We see the thing on the end, and this is where our iterator is. This is the thing that happens at the end of the run. So this sets up the very beginning. This middle thing determines whether or not the loop runs. So as long as the statement in the middle evaluates to true, the code down here will run. And then once it runs once it goes and it executes this code, then it does whatever you select here. Now, take a look at this. What did we learn on Sunday? We learned that we learned about incrementing and decrementing. So the plus right here says increment. So that says add 1 to starting number. So this is the last thing that happens. So this is the first thing that happens in the whole loop. It only happens once. This gets evaluated every time a loop finishes, a loop runs. It says, is this true? Yep. Run the code. Is this true? Yep. Run the code. Is this true? Yep. Run the code. Is this true? Nope. Okay, we're not going to run the code. And so that's how a loop works. And then the last piece is what happens at the very end. And so every time it runs, it's going to go ahead and it's going to increment starting number. So let's write this really quick, and then we're gonna run through it. We're gonna run through this so you can see what's gonna happen, and then we'll talk about like conceptually like what happens on the next run and the next run, so you can kind of follow that. So let's go ahead and write our vim count to 100.go. All right, package main import FAT, and then we're gonna go func main. All right, so we are gonna do for. We're gonna start a for loop. So for is how you set this up. Hey, was it a Do Right? Welcome all the Do Right community. Welcome to Mastermind Academy. I'm glad I looked up and saw the raid before we kind of got into how to write this for loop. Welcome to Mastermind Academy. Tonight we're learning Golang. So we started learning Golang or Go, the programming language Go, on Sunday. This is part 2 of our learning Go. We learned variables and all kinds of stuff last time. This time we're learning all the logic. So we learned about if statements and comparison operators. So equality operators and greater than and less than. And now we're learning loops. We learned ifs and else ifs, and now we're learning loops. So welcome. Thanks for rating. I'm glad y'all are here. Hopefully you can learn something. What do you got? What were you guys working on your channel? Do right? What are you working on tonight? Very interested to know. Hey, 22 Helper, welcome. So, setting up this for loop. So again, the first part we're gonna set up the thing that starts everything. Oh no, your stuff got deleted. Sorry about that. Nightbot doesn't like that. From web front end bugs and input validations primarily. Awesome, that's dope. I'm a terrible front end engineer, so I might have to start watching your stream so I can learn a little bit more about some front end stuff, because I'm a DevOps guy, back end cloud computing, stuff like that. So yeah, even though I am the tech lead on the project where we do Node, React, all that stuff. So I do write some of that stuff time to time, but it is not my forte. Cool, but we're gonna set up this for loop really quick. So for, and again, Go only has for loops. So this may be confusing to a lot of people if you've been using while loops and do whiles and stuff like that. But the first thing we're gonna do is we're gonna set up our counter. So I put starting num because I thought it was very descriptive. So I'll put that here now. So we're gonna make up a variable called starting num. So our starting number, the number that we're gonna start with. And actually starting num is actually confusing because it'll change. So we're just gonna say num. We're gonna say our number is gonna be 0. We're setting up 0. Setting up 0 here. So that's the first piece of the pie. This is the first thing that happens when the for loop runs. So it goes ahead and it steps up. Usually this is used as a counter. A lot of times you can use this as different things, but usually this is set up as some kind of counter to kind of track how many times you're gonna run this and when to stop and things like that. The next thing we had to do was evaluate when this should run. So we've got to do a comparison operator. We talked about comparison operators. We have to evaluate whether or not if we want to count to 100, we basically want to run this for as long as our number is less than 100. So we want to run this. We're starting at 0. We want to run this until it gets up to 100. So we're going to say run this for as long as num is less than or equal to 100. So very simple. So this is, again, the comparison operator that's right here. Again, someone said Boolean operators, and yes, again, this middle piece will always return a Boolean value. So it needs to be true for this for loop to run. Then what are we gonna do? Then we're gonna tell it what to do after the loop runs. So what we're gonna do is we're gonna add 1 to number every time, and we're going to talk about why you're going to add 1. This is usually the thing that people get hung up on the most. It's like, why are we adding 1 to number? What is that? What does that mean? So we are going to set that up, and then what are we going to do in the middle? We know that we want to print out 0 to 100, and we know that we're starting with the value of 0. So how do we print that out? So we know how to print. So we know that it's format.println. All right, so we got this format.println, but what do we want to print? We know that we have this thing that's going to be counting, but it's like it starts at 0. We set the variable equal to 0, but what all it's going to do is print 0. Let's start with that, and we know it's going to print 0. And we know we want to start with 0, so let's do this. So we're going to do this. Actually, I like someone said infinite loop there. I kind of want to set up an infinite loop, but which will be interesting. But we're gonna run this. So this is gonna count to 100, and we're gonna talk through why. Go run. It's gonna do it really fast too. All right. So ran through, and it counted from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 100. Let's look back at our slides and talk about what happened. So, we're gonna look at the code because I think it's easier if you're looking at the code. All right, and I like num instead of starting num, so it's not so long. So first run, the very first run of code. Really, this is all just set up. Everything that you see in the loop is all just set up. The only thing that's actually running anything is really the code that's inside. So the first run. We said num gets set to 0, and this only happens the first time you run through, the first time the loop runs. So when num is 0, then it goes over here and it says, hey, is the variable num, is it less than or is it equal to 100? And yes, it is. 0 is less than 100. So that says, cool. That means we're good to go. We're good to run our code. So it drops down and it says, all right, I'm going to go ahead. I'm going to print num. So the first time this runs, num is 0. So it prints out 0. You can see the very first time, what can I do? You can see the very first time that this ran. Hey, Bearsy, thank you for the follow. Welcome to the stream. Welcome to the family. So the first time this ran, this did in fact print 0. And remember, we use that print line instead of print, so it drops down to a new line. But how does it know to print 1 the second time? So the way that it knows how to print 1 the second time is at the end. Remember, I said this is the thing that happens every time it runs. So it goes and it runs our code. Once it completes our code run, it says, all right, I'm going to increment num by 1. So now number is actually 1. So at the end of the run, num is now 1. And so remember I told you that this only happens the first time it runs. So after this first time, like this goes to run, this is kind of gone. You can kind of throw this out. So now num is 1. After it's 1, it goes through and it evaluates again. Remember, variables can change, so we've changed it to 1. And it says, is 1 less than or equal to 100? Absolutely, it's less than or equal to 100. So remember, when this is true, our code can run. It goes ahead and it runs our code. So what is num this time? Num is now 1. So it prints 1. And then after it's done printing 1, it goes ahead and it runs this and it adds num plus plus. So it increments by 1 again. So now number is 2. And so basically, this is how we use it to get all the way up to 100. We use it to say less than or equal to 100, because if we don't do the equal to, these are those off by 1 errors I was talking about in the beginning. It'll only print up to 99 if we don't do less than or equal to. And again, why is that? That is because when it gets to, when this goes through and it goes through 99 times or whatever, it'll get to say num, when it gets to 100, when num is finally equal to 100, it'll say, is num less than 100? 100 is not less than 100. 100 is equal to 100. And it'll say, nope, that is not true. So I will not run. So once num gets to 100, it will evaluate to false and it'll never print out the number 100. So you can either go less than 101, that'll work. That'll give you to 100. Or you can go less than or equal to, which makes a lot more sense in my mind. But that is how you count to 100. But this is how loops work. And I can show you again, I'm going to show you another way you can do some things. But that's what happens the second run. After the first run, this starting number, this counter that we set up, gets incremented. So now it is 1. Runs again, it gets incremented, now it's 2. This gets evaluated, it runs, gets incremented, now it's 3. Runs, incremented, now it's 4. So again, I know that concept of loops can be super confusing, especially for loops, because all the other loops, you can actually use for loops like while loops, which is pretty interesting. I didn't know that at first when I first learned Go. We're not going to learn that right now. This is the concept I want you to learn this one, because I think once you learn this one, stepping down through the other loops is going to be pretty simple. But again, in Go, there are only 4 loops, but we can use them in a little bit different ways. Cool. Take that in. Yes, and we can use this to count to whatever we want. So this is just a simple for loop to count, but we could use for loops to do all types of things. Maybe if you weren't, let me think of some practical real world things you could do. Let's say I was given a list of names, and let's say I wanted to check, maybe someone gave me just a text file with a list of names. Maybe your code, maybe you have to write a script, maybe it has like thousands and thousands of names in it, and you want to know how many John Smiths there are in this list of names. So thousands of names. You want to know how many John Smiths there are. You could use, there's some packages in Go that you can import this file into your code, and you can have this list. You can have this list of things, and you could iterate through that list using this for loop. And you could say, we haven't learned about length yet, but we're going to learn about length yet. But let's say we had a list of we taught you, I think I taught you about, why is it doing inconsistent tabbing? So let's say we have this list of names. So let's say names, which is actually going to be a slice of string, which I can do like this, and I can do, let's see, James. Let's go, Aaron. Let's put in James again, just so we have something in there twice. Let's go Tom. And I don't really like Tom Brady, but that's what came to mind. And we've got Brady. So we set up this like list. We set up this slice of strings here. We set up this list of names. And maybe actually, I'm going to teach you a lot now. I'm going to teach you a whole lot, because a lot of things that we don't know yet. So another thing you can do, we learned about length, I think, in Python, but let's say we want to find out how many names are in this list. There's an operator in almost every programming language that I know of. It's a length operator. It's run in different ways. But first, let me go ahead and print out names. I'm going to go ahead and print out names first. Whoops, did I miss something? Whoa, what is happening to my buffer? Names equals, that looks right, but it looked like it didn't like that. But I want to run it. Non-declaration, expected type. Oh, I think I have to do string to tell it type. So Go is statically typed. So this looks a little better. All right, so we have this list of names. And maybe we want to write a loop to check for how many times the name is in there. So maybe we're looking for someone's name in particular, but there is a way to find out how many names are in this list. So maybe it's Lane. I don't know. This feels right. Cool. So length is an operation that exists in most programming languages, if not all of them, that allows you to find the amount of items in any type of iterable object. It allows you to find the amount of things that are in something. So this is a list. This is a slice of strings, and it has 1, 2, 3, 4, 5 items in it. And length allows you to do this. Sometimes you can do, a lot of languages, you can do it with like strings. So if I want to know how many letters were in here, I could run a length on that. If I have an array, I can find out how many items are in that array. And so I can use this data to determine how many times I want to loop through something. So, I can also use it to, let's start first. Let's write a for loop. Let's say we want to write a for loop just to print out this list of names. So yes, I was able to print out, let's see, let's save it. I was able to print out the slice itself, but let's say I want to print out each of these on their own separate line. Let's go ahead and let's print these things out individually on each line. We can use a for loop for this. There's better ways to do this, but we're going to say for. You can say whatever you want. You can make a variable for your counter. You can call it anything. So I'm just gonna say X. I'm gonna call it X. And I'm gonna say X is equal to 0. And so that's gonna be my setup. That's almost, you're 90% of the time, you're probably gonna be setting it to 0. But what you can do is now you can, we have to tell it when to run. So I'm gonna say, as long as X is less than, because I want to print out all of these names that are in here. I want to say as long as X is less than the length of names, So this will evaluate, and it'll evaluate to 5. But I'm checking the amount of things that are in names, and I'm saying as long as X is less than the amount of things that are in 5, then to go ahead and run some code that I'm about to write. And then at the end of it, I want you to add 1 to X. Oh man, my fingers are fat, and therefore I make mistakes a lot. And because my mic is in the way, and because, like I told you, I'm a terrible touch typist. I'm getting better at touch typing. That's why I'm building my own keyboard right now. But cool. And we're gonna add that, and then we're gonna go ahead and we're gonna print out, instead of printing numbers as we did before, we are going to print out print line. We're gonna go ahead and print out I didn't tell you this either, but you can do names. I can call it at a spot. So maybe I should show you that first. But remember how we talked about, I think we talked about this for arrays and for slices, and for anything, for these iterable collection of items. So we talked about arrays and slices being collections of things. And so this is a collection of strings. Their locations matter. And we talked about things being 0 index. We talked about that a lot. Talked about them being 0 index. And so because of that, we can refer to each of their locations by number. This being James being in the 0 location, Aaron being in the 1 location, James being in the 2 location, Tom in the 3, Brady in the 4. Even though there are 5 items in here, it starts at 0, a 0 index. This is a common thing. You can refer to their places, and maybe I'll actually, before I do this, actually, maybe you're a Vim master, but I just learned how to block comment in Vim. And maybe there's a better way, but, and I always forget. So I always want to practice every time I can. So I'm going to hit, hold on. I'm going to hit Control B. I'm going to hit down. I'm going to hit Shift I. Put this in escape. Yeah, I block commented, even though that's not the comment, so I will undo that, even though I don't know how to block uncomment. But let's do that one more time, just because I was so happy when I figured it out. Control V, down, Shift I, / escape, boom, block comment in Vim. Now that was slow because that was a new key binding that I learned. Maybe there's a faster way, but I don't know. Hey, Gifted Lane, welcome to the channel again. Appreciate it. I always love to see you come through. Good to see your name. Good to see your friend. Welcome. The go has no way to loop through a list to use. There are ways. There are ways. You can do a for I in range. Yes, or for X in range. Yes, there are better ways. But again, I want you to learn this way first. I want you to learn the base of for loops before we dive into some other stuff. But yes, you can actually do a for X in range, which will pull through those things. But this is a common thing you'll need to do in a lot of things. So we're learning how to do it without having to use, those range functions, even though it is great. But the Go does allow for that. I didn't want to block comment, but basically you can refer to each one of these things by number. And the way you do that is you call the variable, and then you do these brackets here. You do square brackets, and you put in the number of something that you want. So if I ever wanted to call James, I would say names and then bracket 0, because James is in the first spot. And that would, instead of giving me all the names in this list, that would give me just James. So what will happen here is, because these are can be identified by their numbered spot, every time we run through this list, we can move up 1. So the first time when X is 0, and this goes through to run, names X, so names 0, will actually print out James. It'll refer to James. And then X will get 1 added to it. So the next time this runs, X is equal to 1. So it's going to print out names 1. And names 1 is actually Aaron. And then so on to finish out. So let's run this and just see if it prints out what we think. So there, it runs through this slice that's here, and it says James, Aaron, James, Tom, Brady. Now let's combine some of the things that we learned. We learned about the for loops, but let's put an if statement in here. And let's say we wanted to count up. How many times James was in here. So you see James is in here twice, but let's say we wanted to see how many times James was in here. So we could say if we can do if thing. So we knew we can do some comparison operators. So we can say if the name that we're currently on. So the name that we're currently on that we just saw with the print statement is names X. So that'll refer to whatever number run this is on. This will pick a name. So on the first run, when it's 0, it will pick this name. And the second one, when X is 1, it'll pick this name. So if names X, actually maybe we don't even want to count how many are in here, but we'll say if name X equals James. Oh, undo. If name X, what am I doing here? Equals James. What time is it? Okay, cool. James, then go ahead and format dot print line. Go ahead and print out hello James. Very simple, dumb piece of code. All right, so now we've combined a bunch of things that we had. And again, syntactically, this may be super confusing. Hopefully, don't focus on that right now. Focus on the concept of what we're talking about. So we're gonna run a for loop. This loop is going to run for as long as X is less than the number of items that are in names. So names up here has 1, 2, 3, 4, 5 things in it. So as long as X is less than 5, this code right here will run. When it runs, it will check to see if whatever name that we're on, so if names X at whatever location that number is, it's gonna go through the first name, which is James. It's gonna say, is James equal to James? If it is, it's gonna say, hello, James. If not, nothing happens. The code continues. We add 1 to X and it runs through. So it should say hello, James 2 times. So we have James here and we have James here. So this hello, James should only print out times. And we see hello, James, and we see hello, James. All right. Again, I know that can be very confusing. There's all these colors. There's all these numbers here. So again, this is not this Go section is not to get you to learn how loops really work. It's to show you how loops work in Go, so that you can go learn a little bit more about Go yourself. But it is not so that you can really understand how to program. That's what the Python course is for. So if you're interested in learning more about loops, check that out. So now we're gonna combine everything that we've done, and we're gonna solve some problems in a second, after we talk about functions, and then we're gonna do some problems. So won't it technically miss Brady if the comprehension list is just less than? Yes. So we talk about off by 1 errors. So we talk about off by 1 errors when counting to 100. So this right here actually isn't printing out Brady, and we can actually see when we were running it before. Let's make sure this is saved. It actually printed out Brady, but I think I had the greater than in there. But what this will do is actually, sorry, no, this will not. This will not. This will print Brady. It will print Brady. It'll print Brady because this is 0 indexed. So the first run, it'll be 0, and 0 is less than 5, so it'll run. Second time, it'll run 1. 1 will be in the errand spot. Is 1 less than length names? Yes, it'll run. 2, 3, 4. This is actually Brady's only the 4th spot because this is 0 indexed. Brady's actually on the 4th spot, but there are 5 items, so that will work. So that's where the off by 1 errors come the most when you're dealing with arrays or any object or data type that is 0 indexed. But yeah, it's super confusing sometimes. I can't tell you how many times like we've done things like we were just running a script where like we were trying to follow the numbers and we were like, oh, like if it fails, like do we restart on +1 or do we restart on -1? It was like, ugh, like we all know this stuff, but like, why is it so confusing? And we were just going back and forth. But no, not your bad. That's a great, like, again, like I said, none of this is about being right or wrong. None of it is about being right or wrong. It is, hey, if you looked at it and you're like, like, I think that it should do this. Like, say that, bring that up, because we can talk about why it might be. I may be wrong. I may be completely wrong, way off base. I may have forgot to say something or do something, or like bring that up. We'll talk about it, because maybe it's a case where both of us are right. Maybe it's a case where, like, I don't know, there's something that I'm not doing right or I've missed in this problem. So bring it up. Bring, like, whatever questions you have. If you think something's right or wrong, bring it up. Feel free. I'm never gonna be like, nope, that is wrong and this is right. No, absolutely not. I get a lot wrong, and I like to learn too. You guys, again, I've already used, let me tell you, I've already used the // thing, because now that I know and I'm confident in my / and // whenever I need to identify a slash, which is surprisingly often, I use you guys thing. I says, hey, that slash has feet and it is leaning forward or it is leaning backwards, and I am correctly able to identify this slash, and that's because of you all, and I appreciate that. So I'm hoping to learn more. I like to highlight something I've learned from the chat every boot camp, and last boot camp, the big highlight was CD-, for changing directories. Never knew about it, and this // man, my whole life I've been trying to remember which one's // and you guys have done that for me, and I really appreciate it. So the last piece, we're talking about reusable code. So I don't want you to confuse loops with reusable code. Yes, loops have pieces of code that run multiple times. I do know about CD dot. You got to know about CD dot to get back. But CD- that's a good one, and I'll show you why it's a good one. We're gonna learn about Git tonight as well, but I forgot about that. But functions. Functions are reusable code, so it's not looping over code over and over again. Functions are basically taking a piece of functionality and putting it into its own little block of code so that it can be called and used anywhere throughout your application. So not only right there in that loop, not over and over again right now, possibly over and over again right now if you want to use a loop to run a function, but it's a little packaged up piece of code that allows you to do something. And you've already seen a function. So everything we've seen has been running through this weird main thing. This is a function. This whole thing is a function. I told you that every Go program needs a main function. But what did I tell you to think of when you think of functions? And that's these open parentheses, close parentheses. Think about open parentheses, close parentheses, and that's the function. So whatever you see that, it's a function. And so functions are reusable code. So let's look at this, and this will look better in the editor when it has some colors. But this is a function that does something, and it's called I'm the man. This is the function name. So the way that you set up a function is in almost every language is there's some keyword for function. In Go, it's just func. In Python, it's def, which is weird. But it's function. To say you're using a function, same way that you were doing like a loop or if statement, you write function, you give the function a name. So I call this one I'm the man. I don't think functions, there's some rules about capitalization, but as of right now, for your purposes, always make them start with a lowercase letter, and you have some freedom in between. But you call it the name, and then you put in some parentheses, and that's the end of your function name. Now, functions can do two major things, and this is mostly what you're going to be doing every time you're coding. You're going to be taking in data, and you're going to be modifying data, and you're going to be exporting data. That's almost always what you're going to be doing when you're coding. And so functions do exactly that. So function it's possible for a function to take in data, so have some input, and it's also functions also have to have. I wouldn't have to, but functions can have output as well. So what's happening here in this I'm the man string? And again, it'll look better in the editor, but there's a function here, and all the function does is returns a value. So return is a common thing. It's a concept that has to happen in this reusable piece of code. So this reusable piece of code has to return, for you to be able to use anything from it, it has to return a value, it has to return some data. And so return is that keyword to allow you to do that. And so all this function does, it doesn't take in anything, it just returns I'm the man. Every time you run the I'm the man function, all the code does is say I'm the man over and over again. And the way that you run a function is just to call it with the name and put it in open parentheses, close parentheses, and that will run the code. So let's make this. Let's make this really quick. Them the man.go, and let's import. One day I'm going to be able to spell and type properly. So functions, they all look like this. Func is the keyword, and you can see it changes colors. And you need a func main. So you always need a main function in your code, but it doesn't have to be the only function. Go needs a main function to run, but it doesn't have to be the only one. So let's do this. This is gonna be a little bit weird. So we're gonna make a new function besides func main. We're gonna call it I'm the man, and all it's gonna do is it's gonna return. It's going to return the string, I'm the man. All right, now we set up the function. This is a complete function. This is wrong. This function wouldn't work as is. And take a look here. I wrote string right here. What does that mean? So remember how I told you a function can take in data. It can take in input and it can output things. So in Go, this is not true of other languages, but in Go, you have to be explicit about types and what you're going to take in and what you're going to export, or what you're going to put out, what your output is and what your input is. So what you want to input is basically happens in these parentheses. If you're gonna take in an input, it's not a requirement, but if you want to be able to input something into your function, you have to express it here inside the parentheses. But we're not going to take in anything because all this function does is spit out I'm the man. So because it is returning something, we have to tell it what type it's going to be returning. So after the parentheses, we have to tell it which type it's going to be returning. So this function says it sets up a function called I'm the man. We know it's a function because it says func, and it has the parentheses here. We can tell that it doesn't take in any data, but it outputs a string. It has to output a string, and basically whatever is returned has to match what's up here. So it's going to return I'm the man, and the way that you call it, I'm going to call it in this main function is I'm going to call it with I'm the man, and that's all you got to do to call a function. Now, let's run this. All right. So what our error was, I want you to get comfortable seeing errors. It's letting me know which file. So the man.go, that's the one that we ran. On line 3, starting at character 8, imported and not used format package. So I imported a package that I didn't use. Remember, we talked about Go being very efficient. It won't let you import packages that you don't use. Won't let you create things like variables and constants that you don't use. But I'll go ahead and I'll comment this out and I'll run it. And I didn't get an error, but I also didn't get any output. Why didn't I get any output? Didn't get any output because the code actually ran, and it ran successfully, but I didn't tell it to do anything. So notice in here, I commented out the FMT package. We know the FMT package is used to display output. You know it's used to display output. So obviously, if I'm not using that package, then I'm not going to be displaying any output. So how do I see that output of this function? The way I do that is I just print it. So I format.print. And so format.print is a function. So every time you see these double parentheses that we put everything in, this print is just a function. Format.print is a function, and you are passing in, remember I said functions can take in input. You are sending in this function, I'm the man, as input into the print function, and it will go ahead and evaluate that and give you some output. So let's run this now. And now all the output we get is I'm the man. So we basically can write this piece of code and leave it there. And every time we need to say I'm the man somewhere in our application, because applications have multiple files and be very large. And every time I only want to be able to, if I write a piece of code that has functionality that can be reused, I want to package it up in a way that it's easily reused, and functions are how you do that. So we see how you write a function that has some output, but let's see how you write it with some input. So this function will say I'm the man, but we'll say it with your name. So let's write a function to do that. So we're going to modify this. Actually, we'll leave it there so that you can see it. Actually, no, we're not going to leave it. We're just going to comment it out again so I can practice my new Vim tricks here, because it's cool. All right, we block did that. And we're going to make a new function. So we're going to make a func. I'm the man again. I should have just copied everything. But we'll get some practice typing. Now, this time, actually, let's just set it up first. We know it's gonna output a string. All right, and we know it's gonna return. It's not gonna return I'm the man. So we have this function. Only worry about this. We set up another function called I'm the man. We know it's gonna output a string. But this time we want the function to basically, for the user to be able to pass in, we want to be able to pass in a name, and we want to say that person is the man, or my name is the name and I'm the man. So we have to tell it that we're going to pass in something. So first thing we tell it to do is, as input, we say, we give it a placeholder value. So it can be X, it could be name, it could be the Y, it could literally be anything. It's a variable. So you want to make it descriptive. So I want to say I'm going to pass in name. I'm going to pass in a name. It's very descriptive. So when someone else is looking at your code, they can understand what they need to pass into a function to make it work. So very descriptive. I put name there, and again, like I said, it could be anything, X, Y, whatever you want it to be. But you also have to tell the type of the thing that you're going to pass in. So I'm going to be passing in a string, which is name, or I can say maybe instead I was going to pass in my age, so I was going to pass in an int. Doesn't really matter, but for this one, we're going to be printing out the person's name with this. So they're going to be passing in a name, and it is going to be a string. It's also important to know that you can take in multiple things and you can output multiple things. So I can just put a comment here and I can say name string, and maybe I'm also going to pass in age, which is an int, and maybe I'm going to pass in height or something, which is a float, 64. So you can see that you can just, with a comma, you can tell it all the different things that you're going to pass in when you use this function, and you have to pass those things in for this function to be used. Right now, we are just going to use name. Let's go ahead and look at this, and we're going to say return name plus is the man. So I'm going to say I'm the man. So return name. This song has words. I hate it. It like throws my thinking off so much when I hit a song with words in it. It's really weird. I need to get over that. Name plus is the man. So who can tell me? We actually didn't learn this. We actually haven't learned what I'm doing right now in the Go course. We learned it yesterday in Python. Who can tell me when I do name plus the string is the man, what's that called? What is that called when I do that? I'm not moving on until somebody tells me. Concat, yeah, it's called concatenation. String concatenation is what we're doing here. Name plus, when you, the operation of adding two strings together end to end is string concatenation. So we also, it is, I actually like that, FMOMO. It is actually also a little bit of interpolation. It is interpolation, kinda. It is going to evaluate name here. It is not internal to the statement. So usually it's going to be a single string, and it's gonna do it internally. But it kind of is string interpolation as well. So this should return whatever name I pass into it, and then it should append, or it should concatenate it with the string is the man, and we'll give that an exclamation point here. And then how do you pass it? So before we called the function with I'm the man, and that's what it's called. But how do we pass in something? So in the parentheses here, we said we would pass in a name, and it needs to be a string. So this is where we have to pass it in. We pass it in inside of the parentheses. And we can say we're passing in a string. This is a string. And that's going to be the name that takes place. So we're going to pass name into here, and it should return Aaron is the man. Go run, Aaron is the man. Perfect. So you can see how maybe I don't know why I would want to use this over and over again, but a function allows you to basically, all you need to know is it sets up a reusable piece of code that you can call by name. You call it with the parentheses. You need to know that functions can take in input, and it can take in multiple inputs. You know, as long as you just separate them by a comma, they can take an input and it can produce output. And you have to express what types those are. And then you just write your code in the middle of here. And again, reusable pieces of code. Functions are great. You'll use functions all the time. Use functions all the time. So, okay, it looks like you guys are trying to pass me all kinds of Linux commands. I'm telling you, Linux is the thing that I know probably the best. So that's why CD minus took me by surprise. So it's going to probably be pretty hard for you to get me with like a basic Linux command that I don't know. Like CD minus was so basic, but it really changed my workflow. It changed a lot. So yeah, I know about CD. I know about CD takes you home. Yep, I got all those. I'm waiting for some more gems, some simple gems. Like, yeah, there's tons of weird put together commands that pipe a lot of stuff together that do some cool stuff. That's cool. I want to know about the simple stuff that I didn't know about, that are really valuable for sure. Again, just like / and backslash, things that I had trouble remembering. Seriously, you guys really helped me out with that. Yep, $ history number. I had no $ history number to go ahead and run that command. Yep. Cool. So let's do two other quick things really quick. So now we know what a function is. And that was the last piece here. Now you're gonna get real fast. We're gonna go over Git. And then Git is gonna be the last thing that we're gonna do here. You're gonna get a real short introduction to Git. And that's what we'll do now. And then after this, I'm actually gonna extend. I'm gonna stay on past 10, and I'm gonna hop in. I'm gonna show you guys what Exorcism is. So if you can stay, great. If not, you can watch that piece later. It's not super essential that you do that, especially in this class. The Python one, the Exorcism, will be a lot more important. But here, this is just for fun because again, we're moving on from coding after this. But I want to show you a place where you can kind of practice and learn, and practice some of this stuff, even if it's not with Go. But if you want to extend your coding skills as you're getting into DevOps, you can do it there. So I do want to show you that. Also, just giving you guys a heads up. I'm giving you guys a heads up that we're gonna also be doing 100 days of code. But I think we're gonna start it in another 2 weeks. And the reason we're starting in another 2 weeks is because I want to give the Python course, give them enough lead time to actually be able to solve problems. So to get to the point where they're doing loops and they're doing a bunch of stuff and they kind of are really hands-on, because again, a lot of people in that course are true beginners. So we will be doing 100 days of code. There's more information coming out about that. So again, 100 days of code is just everyone practicing code, some piece of code for 100 days. I think you're supposed to do an hour a day for 100 days, and you will massively increase your skills if you do really attempt to do 100 days of code. Even if you don't get the hour of day, even if you just do your best to get most days of the week, and even if it's just 30 minutes, you would be floored by how much better you get in 100 days. You're doing it every day. So more information to come out about that, but let's go over Git really quick. I'm going to take this code that we've been writing tonight, and I'm going to push this repo up. It's the dumbest repo ever, but you don't even know what a repo is yet, but we'll do that. So you've probably heard of something called GitHub. Maybe you've heard of GitHub, or maybe you've heard of GitLab. Let me go to incognito really quick. So if you want, you can head over to github.com, because we're going to be using GitHub for now. There are different sites for this, and I have some slides for this, but I might go into depth about this later. But so what is GitHub? So GitHub is is a version control source code repository. It's a centralized repository owned by, it's actually owned by Microsoft. Microsoft bought it a few years ago for a lot of money. And what it is it is Git is the technology. So Git has nothing to do with Microsoft, has nothing to do with this site at all. Git is an open source technology that was created by a guy named by the name of Linus Torvalds. So Linus Torvalds is also the guy who created the Linux kernel. So the technology that runs the digital landscape of what we know now, what you're watching on, the thing that I'm sure is serving you your content right now. I'm sure you're seeing this video over Linux servers for sure. But this guy created Linux, the Linux kernel, the engine for Linux, as well as the tool Git. And Git is arguably, to me, it's arguably the most influential developer tool ever created. It's that great. And so what Git does is it allows you to have a distributed. It allows you to distribute and have a distributed log of the history of files and their changes. So it's version control. So the same way that your Google Docs or your Microsoft Word keeps history on the versions, you make changes, it saves the version. You can go back through the versions and things like that. Git kind of does that for code, and so it allows different people to work on the same code base and contribute to the same code base at the same time. Which can be very difficult. Imagine you and you're in school, you're in college, and you're doing a group report, and you and two other people are attempting to write the same paper at the exact same time. Like the way that works would be very tough. It would be very tough. But with code, you can do that. You can really do that. So it's distributed, meaning the history doesn't need to reside in one central location, but repositories like GitHub, like GitLab, like Bitbucket, there's a bunch of them, allow you to create a centralized repository for many people to grab the code from, work on them locally, make changes and things like that, and give you some mechanisms to be able to merge your code back together in a clean way so that everything still works. So it's a pretty big technology. A lot of people think when they first are learning Git, because it's very easy to get the very first steps set up, you're like, oh, pretty simple, I understand the workflow, but Git is it's pretty deep. It's honestly pretty deep. Hey, the Architect, welcome to the stream. Thank you for the follow. But let me show you now that we're logged in. So all your favorite code, anything that you've ever used, so like Chromium. So the Chrome browser, we're using the Chrome web browser. All of the official documentation, all the official code base of Chromium is actually here. It's actually right here. So if you've ever heard of open source software, this is software that is free to use, free and open source software, free to use. The community develops to it. So yes, sometimes these are backed by companies, but anyone can contribute to it. So if you've been learning how to code and someone was like, the best way to learn how to code is contribute to open source software, it ain't that easy. It's not that easy to start contributing or to get to the level where you can really start contributing, but this is what they mean. I can go contribute to Chromium's to what it is. Like I can go add to the software that we use. I can go add to it. So basically what happens is I can actually copy everything that Chromium has here. Actually, I don't think I have a key set up. I can copy all this down to my computer, so I can clone it. And so what cloning does is, this is a central source code repository. So the entire history of this code base exists right now in here. So you can see 853,071 commits. So that's how many times new pieces of code have been added into this code base, and the entire history is here. And I can clone that entire history to my computer, and that's why it's distributed. So every computer, your computer, my computer, we can all take an entire history of this. We can make changes to that history, and then we can push that history back on top of this history. And what it'll do, again, is there's mechanisms in place for it to do that gracefully, to do it effectively. It might make you make changes. It makes sure that if I push code right before you, it will not allow you to push code that breaks things unless you go back and manage your code as well. But on top of all that, it's also just Git and GitHub and these source code repositories are also a simple way for you to be able to save your code. You don't want to save your code locally. Like, it's a good way for you to save your code and share it with others. So we're gonna look at my repositories. What I'm gonna do really quick is I'm gonna create a new repository for the code that we just did tonight. So I'm gonna say I'm gonna call this silly go, silly-go-examples. Really stupid. So we've been making a bunch of files tonight, and we're calling it silly go examples. Really simple. We can put a description, it's optional, and we can say a bunch of silly go explanations. I spelled that wrong. Well, it's not underlined. I don't know, not a great speller, but you have some options here. So you can make something public or private. Private meaning only you and the people you give access to can see it. Or contribute to it. I think this used to be a feature. Private repositories only were a thing for paying customers before, but I think, or like you can only have like 3 private repositories. Oh, sorry about that. I have my berry LaCroix tonight. But when Microsoft took over, they allowed for unlimited private repositories. But you can only have, I think, 3 contributors per repository. So if you have a whole team of people, you have to pay to be able to use it, but you get up to 3 people. So we're gonna make this public so you can get it. And so Git the technology is probably installed on your computer by default. It's very easy to install if not. But the way that you know if it's installed is you just type Git, and if you get some output here, that means you have Git installed. But yeah, I think on every machine it comes installed automatically. If not, if you just Google how to install Git, I think there's a package for Windows, and I'm sure there's one for your package manager, but pretty simple. Now, how can I push my code up here? Like, you might think you can just copy and paste it, like if you were moving some files to one of your cloud services like Google Drive or something, which you can. And there are graphical user interfaces for stuff like this, but because of the way that Git works, the technology of Git works, and the way that it manages the history of your files, that's not really the best way, or something that you can always do. And so we're going to create a repository. So there's some options here. We're not going to do any of this stuff. We're also not going to talk about what these things are right now, because I'm actually doing. I'll submit the date for like the confirmed date, but a little bit later in I think it's in February sometime on one of the Fridays. One of the Fridays I had carved out for like office hours. I'm actually doing an entire 2-hour Git workshop instead. Because Git is pretty powerful. And again, I wanted to make it during a time once the people in the Python course kind of got far enough to where they had code to be able to push up to GitHub. So we created a new repository. Again, this repository is just a holding place for your code, a box in which to dump your files or anything. So once we get to Docker, we can talk about container repositories and image repositories and things like that. But a repository is simply a place that holds your code. And so we've set up a repository here that's going to hold our code, and then it gives us some ways to be able to push that code up. So you'll hear the word push a lot when we talk about Git specifically. And so again, Git is a technology that exists outside of these services like GitHub. And Git can work with a bunch of different services. There are services like there's GitHub, there is GitLab, which is a cool company. A bunch of people decided to go to GitLab when they heard Microsoft was buying GitHub. But yeah, GitLab's cool. It's also a source code repository, but plus some other stuff. There's a Bitbucket. Yeah, there's a couple other ones, but these are kind of the main ones that people use. But again, version control and source code control software. So what we're gonna do is we're gonna make a repository locally. So this is a repository, but we actually need to make a repository locally. So we're gonna take these files that we have here. These are all the files that we wrote tonight. But I can make this folder that they're in, I can make it a Git repository. So I'm gonna type in Git init. And so what this does is it says initialize empty Git repository. Now, Git, again, has nothing to do with GitHub. So right now, this repository knows nothing about GitHub. I can manage all of the history of these files right here on my machine if I'd like. Like I can just use this machine as the thing that's managing this. I could use this machine as the repository for, a central repository for other people. I could use this as, the source of truth for a bunch of people to be able to pull code from. But that's not very good to do because you may lose your computer, they may get corrupted. You want to use a service that's more robust, that's more reliable. And again, it's free. So go sign up for a GitHub account. I encourage everyone to sign up for a GitHub account. So this initiated a repository. So this line that we have, so it gives me some options to push an existing repository from the command line. We just created a repository, and this allows us to add a remote origin. So basically, this allows us to add a remote centralized server to be able to push our code to. And this is just as simply it's simply a link to GitHub, and we're gonna copy that and we're gonna paste this in here. Whoa. All right, paste it in. All that did was set up. So when I made this Git repository, when I did that Git init, it opened up this .git file, created this, and inside this .git file, there are some files here, and these are all the files that manage what's going on with my code. It manages the history, it figures things out. So in here, there's this config. And in here, when I ran that remote command, it went ahead and it added this URL here. And so all that does is just tell my repository that there's a place that's managing my code, that's kind of the source of truth that I should be checking in with. If the user of Git tells me to check in with or look for code, this is where I'm gonna go look. So that's what that line did. And now what we can do is what everyone knows to be the main pieces of Git. So what everyone knows about Git, what everyone knows about the Git workflow is you have a Git repository, you write some code, you make changes to it. And then once you make changes to those code, once you want to save those things in Git, once you want to make a commit, remember I showed you there were 800,000 commits. That's kind of the act of saving a file at a point in time. And then when you want to push that history up to GitHub, that workflow is pretty simple. It's 3 different things. So I actually say it's 4 different things. So you have some commands available to you. So we have git status. This will tell you what's going on. This will tell you, what the status is of the current repository. So it lets me know I'm on a branch master. So a branch is just it's a branch of code. It's a version of code that can differ from other versions. So right now we're on master. Master is usually the source of truth, the main branch. But if I'm working on something, I can create a whole new branch. So imagine a tree that's growing like your code base. If I want to work on something, I can branch off of it and I can start writing some code over here. And then when I'm ready for it to be good and I've made it great, I can merge it back into the main tree, which is really interesting. Again, we'll get a lot farther from there. So we have a bunch of stuff here. It says we have all these files and they're untracked. So Git, again, is tracking the history. I have to explicitly tell Git to track all these files. So the way that you do that is with an add command. So git add, and I'm gonna go dot. So don't get in the habit of doing this. I could say, actually, I'll do it with one file at first. I'm gonna say git add andor.go, and I'm gonna do git status again. Now you can see it's green and it says, hey, I'm tracking this file. I know this is a file I need to track, and but there's no commit. So you haven't done a point in time save of this file. But you can, now that you've added it, you can go ahead and do a point in time save of this file, and we will go ahead and commit that to our memory, commit that to our history. So I need to add all these files. So the way you can add all of them is just the git add dot. That'll just add everything that's currently in this folder where I am currently. The dot represents my location here, but don't get in the habit of doing this. I'm just doing it now for time's sake. Do not get in the habit of doing git add dot unless you know exactly what files are there. I've seen people commit all kinds of formatted files and all kinds of other stuff. So yeah, we got all our Go files in Git now. You can see that they're all green and they're ready to go. So Git status. So this is the workflow to start. Like if you're just trying to get introduced to Git, do a Git status, see what's going on. Git add the files that you need to add to the history to add to be tracked. Now we need to go ahead and commit those files. So now we're ready to go. We've made our changes to our files. We want to make a point in time save of these to be committed. So we're going to do a git commit. And when you do a commit, you want to give it a message. So you do a git commit -m, and you want to give it a message of what you've done. And I can say added the files we worked on from the stream. Now you want to be very descriptive with this. That was a terrible git commit message, but these git commit messages are important. I'm going to show you why in a second. So you want to be kind of descriptive about what you did. If you added a variable or if you wrote a new function to do a certain thing, you want to write that in there. I wrote a new function to be able to say I'm the man or something like that. You want to put that in there. And then, so now you've committed this to the history, and you can actually see I have some helper things in my terminal to tell me what's going on. When it was orange, it was telling me that changes have been made. That's why the plus is here. And now that everything's green, it's letting me know that everything's been committed to master. So everything's committed and the history has been saved. Now, the last thing I need to do is if other people are working on this with me, or I want to get it to GitHub so that I have a centralized place where the history of my files are, I have to push that thing. So you only have to do this the first time. Well, you have to push every time you want to push up code, but you only have to do this -u origin master. So I told you about that master branch. This lets me know I'm on the master branch. And you push up your code and I actually don't know. I usually use SSH, so I don't know if that's the mastermind IO. All right, cool. And so ask for your username and password, and it pushed it up to GitHub. And we can see here, if I refresh this page, now all these files that we just worked on, they're now here and they're available for you to grab. So I'll send you, oh no, back. I'll send you this. You can now clone, you can now grab these files if you'd like them. And so that's why they're good to be in this remote place. If you like to grab them, you can get into there. You could just download them if you wanted to, but once you're signed up and set up with Git, you can clone them. So cloning allows you to take the entire history. But you can see here, I have a single commit. I've committed one thing. You saw me do one commit, and it has the message added files we worked on from the stream. This is very descriptive about what you've done. So you all would be able to, you could pull this down if you wanted to add files you worked on or whatever you wanted to do. You could actually contribute to this and submit what's called a pull request. And basically it would be a request that says, hey, I wrote some code to make your code better or to extend some functionality. Can you take a look at it and possibly add it to your code? And I will go through here and I will look at it and I would say, great, thank you for adding this. I'm gonna put it into my code, and it would merge our code together and it would be great. So it allows for it allows people to collaboratively work on projects. And so it's a pretty great thing. But that workflow that you just saw, very simple. Let's do a history. We just want to see the last like 5 things. Oh, can you not pipe? Yeah, there we go. I forgot the dash. Perfect number. So this workflow is kind of the workflow that everyone knows. You add, you commit, and then you push. I always say use git status to figure out what's going on, but you add your code to be followed, to be tracked, commit it, to kind of save it to a point in time, and you push it so that it goes to a place that's available to everyone that you want to have it. And that's kind of just the workflow that you have there. It gets a lot more complicated than that, but Git is great, again, for that reason, for people to be able to get your code, to see your code, to share your code, to contribute to your code collaboratively. And that's all Git is. That's all GitHub is. And I wanted to tell you about that because we're going to be, a lot of the stuff we're going to be doing from now on, I'm going to be basically giving you links to GitHub so you can download stuff. So yeah, just wanted to go over a quick thing about that, and so that I could start showing you Exorcism, and that we could start building a repository of Exorcism solutions. So, oh yeah, gitlog-p, that's really nice too. So Git also allows for a lot of other things. So you can do a git log, and it'll tell you everything that happened. It'll tell you when someone committed code, so that's important. You can tell, I can see the commit that it was, and gives me, you know, some extra information. So that, like, again, Git adds a lot of things. Don't expect to know everything that's in Git from day one. The -p allows me to see the diffs. So this is actually how Git knows what to change. So every time someone commits code, it creates these things called diffs, and diffs are basically the changes, all the deltas between the old state of the file and the new state of the file. And then when someone else needs to apply changes, or you need to pull code down that applies changes, it goes ahead and it runs through these diffs and applies these patches that it creates in order to be able to get a piece of a code base up to the same place. So it's very interesting. It's pretty robust. It's not foolproof. There's a lot of times when you run into issues, but it is a great way for people to work on code collaboratively. Now, last thing. So again, that's kind of everything that I wanted people to know for tonight. Now, if you can stay on, if you can spare a few more minutes, I want to introduce you all to Exorcism.io. So we talked about, this is the last piece of coding for the DevOps Bootcamp, but you might want to continue to get more practice. You might want to learn, you might want to practice how to code more, and you should be learning how to do these things more and more, and you should be diving deeper and deeper into the concepts that I give you. But head over to Exorcism.io, sign up for an account. You can sign up with your GitHub account. So if you've just signed up for a GitHub account, you can hop right into Exorcism.io. Once you get inside, again, this is simply a practice site. There's a lot of sites to practice code, a whole lot of sites to practice code. The reason that I like to use this one is because they actually have mentors. They have real life mentors that go in here and provide you feedback and solutions to your problems. And once you submit answers for problems, you can simply you can see other people's problems as well, answers as well, so you can kind of learn that way as well. Really cool. I just think it's a really cool thing. I think it's a really helpful platform. So as you'll see, you can pick a language. So if you don't want to learn Go or practice in Go, when you're learning a different language, no big deal. You can pick whatever language works for you that you want to know more of. It's interesting because I actually think Go has the most exercise. Oh, I lied. Python now has the most exercises. It was Go for a while, had the most exercises. So that can show you a little bit about the popularity of some of the languages. Because some of these you can see have 27 and Ruby only has 96. And again, that's because some of the problems can't be switched up to kind of work with other languages quite as well. But there is a learning curve here to not just solving the problems, but there's a learning curve to being able to send in answers and to know how to solve them properly. So you can do them in two ways. And I actually don't encourage you to, at first, if you're just starting, I actually don't encourage you to solve them in the way that they want you to solve them. So let's just take a look at, I know one of these is like FizzBuzz, but you click on a problem and it'll initially give you what the problem is. So you can read through to see if there's a problem you want to work on. It'll give you an introduction. It'll tell you exactly what to do. It'll tell you exactly what to do to solve the problem. But all of these problems follow a what's called test-driven development they all follow a practice called test-driven development. So you are actually coding this to be able to make it pass some tests. So test-driven development, definitely, again, I said write down things that I say that you're not unsure of. If you're trying to do DevOps, this is something that you should be familiar with, or a concept that you should be familiar with. But test-driven development is actually where you can programmatically write test cases to check your code, to check if your code is correct or not. That may be hard to conceptualize right now before you know some more code, but it's a thing that you can do, and you can write these test cases to basically say, hey, I expect that when I pass in this to this function, that this is the output, and you can use these tests to confirm that your code is working properly. Test-driven development is a coding practice, where you write your tests before you write your code. So you write tests that answer cases that would cause your code to work properly. And basically what you do is, once you build the test first, all the code will fail. The test will fail because you don't have any code. And then you write your code to in order to make the test pass. So it hopefully, the goal is to help you to be able to write better code that solves the problem, because you've thought about how you want to test it first. There's data that says it's not actually a valuable practice, but super debatable. So when you download these things, they come with tests. They come with tests that are already written out for you, and they do help you solve the problem if you know what you're looking at. But I think there's a level of learning that has to happen for you to make sense of the tests and use that to help you. So let's take a look at one. So let's download one. So basically, the first time you get in, you actually have to set your computer up to be able to do this. So you go through this walkthrough. This computer is not set up for it, I don't think. It asks you, what for an installation guide. Actually, let me check if this computer is set up for it or not. Whoa. See. Okay, this computer is set up for it, so cool. So I don't need to go through the full setup, which is good because I don't want to take too much of your time. But click your OS and run through the setup. Not important that you do it right now. I just want to show you what it looks like first. Get a feel for what it looks like first. Go through and get the setup, and it'll get you set up to be able to use this. But once you get that set up, to be able to download the problem, you can go ahead and you can copy this download, and you can download it to your computer. I'll paste it in, and it downloaded it. It tells me where it downloaded it to. So I'll go here really quick. All right, so I've got this. It downloads a bunch of files. So Raindrops was the problem that I downloaded. And basically all it does is it downloads, a README, which has, what the problem is, and kind of how to solve it. It gives you a test file, which is a test file, and for Go, it gives you a file that has some test cases in it. So let's take a look at the stuff that's in here. So the README is just the information about that, the same information that's right here over on the left. The README will have in it. So READMEs are files. Whenever you see a file that is in all caps that says README, it's because it wants you to read it. It usually has information about either how to use this application, how to run the application, how to how to do different things with the application. It has the instructions for managing the application. So check out the README. So it has that, but then it has a .go file for whatever the name of the thing is. And this is the file that they want you to start modifying here. But it also has a test file, which is confusing. So if you don't know anything about Go or tests, this is crazy confusing. So when you first download this stuff, this is why I'm saying do not try to pass the test first. Just try to do the thing that it says. You can open up your own file, just start working on it. You do not have to get it right. You don't even have to get close. Open up a file and start trying to do the thing that it says. So read the README, try to do that thing, but I don't think you need to code to the test at first. And then at any given time, you can submit even this. You can submit an empty file and then be able to see other people's answers. So practice on the file off to the side. See if you can get it to do what they want you to do. If you're unsure, reach out for help. See what you can figure out. Submit it so that you can see all the other people's answers, and maybe look at someone's answers and see if you can start to like break down what they did. I think it's a powerful. I think it can be pretty powerful when you're trying to learn how to code and learn how to like think about how to solve these problems. But yeah, so they'll have this test file. And so again, once you're comfortable knowing what you're looking at, you can kind of look in here and see what I'm trying to solve. And so basically for Go, at least to help you out, if you look at the cases_test.go file, I think all the Go ones will have a cases_test file. All you got to do is look at this, and there will always be an input and an output. So basically, this is basically saying, hey, every time I pass in, when I run this the first time and I pass in 1, I expect to get 1. And when I plug in 3, I expect to get pling. And when I pass in 14, I expect to get plong. And that's kind of how tests work. It says, hey, I'm going to run your code, and I'm going to pass in information that you told me to pass in, and I'm going to make sure that I get the expected value. But again, I think it's very difficult in the beginning to do to work to that. But yeah, read the readmes and practice. So maybe we'll just go over. Let's go ahead and go over this. This is one like this is a very FizzBuzzy type question. FizzBuzz is one of the most common, it's one of the original OG like interview questions, like algorithmic questions. It's a fairly simple problem. Basically, the problem goes like this. It says, hey, I want you to print out the numbers 0 to 100, or 0 to whatever number I tell you to. So let's go 0 to 100. Tonight, we learned in Go how to print from 0 to 100. But here's the twist. When you're printing out 0 to 100, every time you get to a number that is divisible by 3, I want you to print out the word fizz. Every time you get to a number that is divisible by 5, I want you to print out the word buzz. And every time I get to a number that is divisible by both 3 and 5, I want you to print out FizzBuzz. And for every other number, I want you to just print out the number itself. So that's a lot of extra things inside of the 0 to 100. We learned how to print out 0 to 100, and now we've got all these things in between. This one, I saw this the other day. This is like the same thing, but it's called raindrops. It uses some different numbers, and actually it has an extra option here that's not FizzBuzz. Actually, we're just gonna do FizzBuzz so that we don't have to worry about Exorcism. I wanted to introduce you to Exorcism, but not necessarily want to do anything with it right now. But let's go ahead and do FizzBuzz really quick, because FizzBuzz will FizzBuzz ties together all the things that we learned over the past 2 classes, to be 100% honest. It is I'll be honest with you, if you ever go anywhere that asks you as a developer, that asks you to do FizzBuzz for you to get the job, I would be wary of that place. I'm not saying don't take it, but I would be a little bit skeptical of them. But I think this is a really good problem to help people start to get into the mindset of how to solve algorithmic problems like this. So we're about to do some FizzBuzz, but let me get a little bit of Barry LaCroix and answer any questions that were asked before we get into them. What language is? Sorry, that was a Git tutorial, but Go is a language that we're going to be doing this in, that we're going through right now. Finally got my Exorcism IO to work. It's pretty neat. Yes, you will learn a lot in just getting Exorcism to work. Also, if you're trying to get Exorcism to work and you're just so confused by the setup and the command line stuff, I think that'll change after the next 2 classes that have to do with Linux. I think you'll have just enough chops to be able to get that installed. You'll never be a serious developer if you don't own a .io domain. I agree with you, Thug Muffin. That's why my domain is mastermind.io, which makes me a serious developer. So grab an IO domain today and you can call yourself a serious developer. Do a quick function called sum to demonstrate. What am I demonstrating with that? I could do a quick sum function. What am I trying to demonstrate? I'm not sure if it was mentioned for Git, but I did this the other day and it was pretty cool. Learning Git branching. Oh, this is cool. Yeah. Git is, man, I learned so much about Git this year. And it's mesmerizing, man. Like, Git is a crazy powerful tool that I love. Modulus, yes, we're about to use some Modulus or some Modulo for sure in here. FizzBuzz, wish I got those types of internship questions. Me too, to be honest, but I would be skeptical. Did you ever fix your chat converts something to asterisks? No, I didn't. I'll see if I can fix that with I think it's Nightbot doing that. I'll see if I can ease up on Nightbot because I don't really care. Yeah, I'll see if I can fix that. Let me put that in my Google Keep as something to check out tonight as well, so that I don't forget. I got De Morgan's Law in there, so I'm gonna learn a little bit tonight right after this. Nightbot moderation. All right, cool. So we're gonna do a quick FizzBuzz thing, and actually we're gonna put it in the repository. Where were we? We're gonna put it in the same repository that we were in. CD, was it documents, / documents, so we can push it up to GitHub. I can't remember where we were. Mastermind. No, CD dot. Ooh, CD streams and go. All right, we're gonna make a new file. We're gonna vim fizzbuzz.go. All right, you're gonna learn right now how to do the most sought after programming problem that ever existed, ever. So get ready. Let's add in all the things that we've learned so far. We're gonna add them all up. So first, what we're gonna do is we're gonna import Fumpt really quick because this is the only package we're gonna need. We're gonna go ahead and write. But we're gonna write down the problem right now, what FizzBuzz is, so that if you clone this, if you download this, I want you to know what FizzBuzz is. So FizzBuzz, print numbers 0. We're gonna start with 100, 0 through 100, comma. But if let's go like this, so we have it here. 1, the number is divisible by 3, comma, print fizz. 2, if the number is divisible by 5, comma, let's go ahead and let's print out buzz. And then the last one is 3, if the number is divisible by 3 and by 5, comma, print is buzz. All right. Now we've got our problem here. We can read it. We can reference it right at the top. Hey, Film Raw, thank you for the follow. Welcome to the channel. But we got our FizzBuzz stuff here. We're gonna learn how to do the infamous FizzBuzz. So let's start off first. We know that our Go code needs a main function. So let's go ahead and set up our main function. So func main, everything you need to write Go is now here. Cool. So we're set up, we're good to go. We can write all of our FizzBuzz right in here, to be honest. We could make another function, but we're just gonna, we wrote our func main. We know what functions do. We know functions are reusable pieces of code that we can call anytime we want to, but we're gonna write it right in here. So let's start out first. Let's start out very simply, and let's print the number 0 to 100. And again, let's go ahead and use our for loop that we learned earlier for more practice. So we're gonna say for num equals 0. We're gonna, instantiate our variable here, declare and assign our variable, set it to 0. So if we want to print from 0 to 100, we're gonna say as long as our number is less than 100, go ahead less than or equal to 100, we want our code to run. So remember, this is the statement, that middle statement right here. The second statement is the one that gets evaluated. And as long as this is true, this code will run. And at the end, we're going to do num++. For almost all of your for loops, this is going to be the breakdown. Like it's going to be something being 0, and the end's going to be that same thing getting 1 added to it. And then the middle is going to be whatever you want to evaluate. So yeah, I know it can be confusing sometimes figuring out what you actually want to increment or figure out, but it's going to be very similar to this all the time. And I know all these colons and semicolons and curly braces make it a little confusing, but again, I want you to understand the concept of a for loop instead. So we want to print out that number. So we want to format that print line. We want to go ahead and print our number. So what this little bit of code should do is go run. It's going to run. It's going to print out whatever num is. So the first time num is 0. Then it's going to add 1 to num. And the second time, since it added 1, num is now 1. So it's going to print 1. And it's going to add 1. It's going to print 2. And it's going to add 1. It's going to print 3. And it's going to do that all the way up until number is no longer less than or equal to 100. So the first number that's going to break this is 101. So once this gets to 101, it will stop. So it will run on the 100th number. So let's go ahead and start and make sure that we have printed out 0 to 100 properly. And again, we didn't stop here for long because we've already done this piece tonight, but we will take our time on the next couple pieces. Whoops, forgot to run. Go run, FizzBuzz.go. So we got the 0 to 100 printed here. No problem at all. Now let's get into the fun. Let's take this case by case. We'll solve number 1, then we'll solve number 2, then we'll solve number 3. So very simple. And actually make this so it's easier if you're looking at it later. I like to use if the number is divisible by 3. So very, very simple. Not very, very simple, but we can read the word and figure out what kind of code to put towards it. So I said if the number is divisible by 3, print fizz. So if I already threw it right at you, how do we check if something is true? We check if something is true by using an if statement. So we learned that. So we're going to say if. We're going to check if the number is divisible by 3. We're just going to say number is divisible by 3. Then print fizz. So an if statement sets up like this. So we're going to check if something is true. We check. Oh, excuse me. Oh, this Berry LaCroix is not agreeing with me right now. I'm sorry about that. I drank all the orange one and I drank all the lemon one. The berry one's, I'm trying, man. Yeah, it's not good. I'm sorry. I will not be getting berry tomorrow. But if so, it's going to say if this statement is true, do something in the middle here, run some code. And the code that we want to run is print fizz. We know how to print already. So let's go ahead and print fizz. So format dot print line. Let's go ahead and print line fizz. All right. So this should actually, I know, oh, you're right. I'm sorry, LaCroix. The berry is the best. The best of the LaCroix is the berry. And I like the orange and I like the lemon because I need you as a sponsor. Even though I don't think anyone at LaCroix has ever seen this stream at all, but you're right. I like that. I forgot. Thank you for looking out. I need to stay positive about LaCroix so that one day LaCroix will be at the center of the technical movement, of the engineering movement. I think I can see LaCroix being at the center of it, and we're gonna start that for sure, because TV static is the only kind of static that anyone wants to taste. You like that? That's a good tagline for LaCroix. I'm sticking with the TV static thing. But we set up an if statement, and we're checking if this number is true. If num divided by 3, format print line fizz. Now, take a look at this. What is one? Remember, I said a comparison operator prints true or false, and that if needs a comparison operator. So, well, it needs a comparison operator or a I don't know the name for the other types of operators that like check for things to be valid or for existing values, but you need a comparison operator here. So I need a true or false value for if to know if it's going to run or not. How do I actually check this? So num divided by 3, what is that going to return us? So if num is 1, 1 divided by 3 is going to return us 0, but that doesn't tell if it can run or not. It needs to be it needs to give me a true or false value. So it needs to give me a Boolean value so that it knows to run or not. How do you know if a number? This is good. This is why FizzBuzz is a little bit I understand why people originally implemented FizzBuzz to check if people knew how to code. How, using the things that we have available to us, how do we know if a number is divisible by something? How do we know if a number is evenly divisible by another number? What is the output? And this might take you back to your 4th grade math class. But how do we know if a number is evenly divisible by another number? What does the output have to be for it to be evenly divisible? No remainder. That's really good. No remainder. So this is where modulus finally comes in. We talked about modulus. We didn't know quite where it came in. So we're not going to use divide. Remember, we learned that modulus does actually divide, but it returns the remainder. If a number is divisible by something else, then there will be no remainder. So we can say if num modulo 3, if the value of that is equal to 0, then go ahead and run this code. So that's what we're doing here. So now we have our comparison operator. We have we're saying is what's on the left equal to what's on the right. So we're gonna say if num modulo 3 equals 0, go ahead and print this. But yes, you don't need the. I actually think you may be able to do it without the equals 0, to be honest. But just for explicit sake, so you can see what's going on here. If num modulo 3 equals 0, go ahead and print fizz. So again, a number that is evenly divisible by 3 will always have the remainder of 0. So again, we can do that. Even Python has this. So let's actually get out of here. We can run it in a second, but let's go to Python 3 really quick. And let's go to numbers that are, Python has modulo as well. So 3 modulo 3 equals 0. 6 modulo 3 equals 0. 30 modulo 3 is 0. So every number that is evenly divisible by 3 equals 0. So that's just a way to show you that is the case. So let's go run FizzBuzz. Now go. All right, let's take a look at our output. All right, so it printed fizz first. I'll tell you in a second why I printed fizz first, and it printed 0. Then it printed 1 to fizz 3. Now we told it to print fizz instead of the number, but we still got 3 here. 4, 5, 6, or where 6 should be, but it also printed 6, 7, 8, fizz 9. So it seems like it's doing the right thing, kinda. It seems like it's doing kinda the right thing. Let's see if we can troubleshoot why it's not printing in place of, but also. So let's take a look at this. So it's going ahead, it's running through here, and it's doing num modulo 3, checking for that, and it seems like it's doing it properly, and it's printing out fizz. But then this, so indentation doesn't matter in Go, but indentation does matter for formatting, like visually when you're looking at something, because of where this is. Well, not even because of where this is, it also has to do with the braces here, but it's running through and it's evaluating the if statement. Even if the if statement is correct, even if it matches and it prints this, it still evaluates this below it because it's outside. This is outside of the if statement. It's not an else if. This line will always run because it's lined up here. It'll always run. So basically, yes, this part is working properly, but it's also still just printing out every number 1 to 100. We actually didn't change anything. We just added some functionality here. So what can we do to, what can we add on as a default case? So if it equals, if num modulo 3 equals 0, we want to print fizz, but every other case, every single other case, we want to print out the number. And someone said it perfectly. We want to add an else. We want to add that default case, because I remember that's why I said specifically every other case we want to be able to print the number. So we're going to add an else statement here. And so basically, again, remember, if is going to evaluate this, and if it's true, if this evaluates it true, it's going to print this. Else doesn't care. Else says, if everything above me did not evaluate to true, go ahead and run me. So let's see what the output of this is. It's clear. Whoops. Go run. All right, let's see if this works. So now we got fizz on 0. Sure. 1, 2, fizz. 4, 5, fizz. 7, 8, fizz. 10, 11, fizz, 13. So every third number basically throughout the entire thing is fizz. 99 is, evenly divisible by 3. So we got fizz. So we got number 1. We've got number 1 knocked on out of here. All right, so let's move to number 2. Number 2 looks very similar to number 1. So if the number is divisible by 5, print buzz. Now, how would we add in another comparison statement to this? We already have an else. Remember, we can only have one if. We can only have one else. What can we do here? We can do an else if. So right here, I'm going to, else has to be last, just so you know as well. It has to be last. So we're gonna say else if. And we can just copy what we have up here. We can say else if, and we can yank this, and we can say else if num modulo 5 equals 0. Oh, this is where the else goes. Open this up. The formatting of this is bad right now. I'm gonna fix it. And this goes up here. All right, so here's the else if. So now, right here we have our if. We said if num modulo 3 equals 0, go ahead and print fizz. Go ahead and run this code. Now we're gonna say else if num modulo 5, so we wanna check if a number is divisible by 5. We wanna print buzz this time. So we can take this line right here, and we can paste this here. And instead of fizz, we're gonna print buzz. And again, these are very similar, so we can be confident that our logic is probably fine here. And so we can print FizzBuzz now. Oh, we can print fizz and we can print buzz, and every other number should print. So let's talk it out. It should print 1, 2, and then 3 is divisible by 3, so we should get fizz, and then we should get 4. And then we should get buzz because 5 is divisible by 5. Then we should get fizz again because 6 is divisible by 3. 7, 8, fizz because it's divisible by 3. Buzz because 10 is divisible by 5. Onwards. So that is what it should do. That's what it should look like. And let's go ahead and run our code. Let's take a look at it. So we have 1, 2, fizz. So 0, when something's divided by 0, the remainder is going to be 0. That's why we're getting fizz the first time every time. But don't worry about that. So 1, 2, fizz. 4, buzz. Fizz. 7, 8, fizz, buzz. 11, fizz. 13, 14, fizz. 16, 17, fizz. 19, buzz. Fizz. 22, 23, fizz, buzz. All right, we got it. We killed it. We're doing really good. We got through 1 and we got through 2 of our problem. We solved each piece. And this is how you should be breaking down problems. Like read through them, do your best to, they probably won't be numbered like this, but break them down into the pieces that you need to be able to solve them. so that you can solve them one at a time. Now, you may have to switch things up later on, but break them down into the consumable pieces that you can kind of mentally wrap your head around and solve. Now, this is always where it gets very fun. And not fun, it's very interesting watching someone do this for the first time. I always see people, even like people who are very new, eventually, again, maybe not with Go, but eventually they get to this point. They get to this point where they can print Fizz and they can print Buzz. And they get to the point where they can print FizzBuzz as well, but there's a lot of caveats here. So I'm first going to implement it the way that I see most people implement it the first time. So we have this else statement, and we know else has to be last. So now we want to check if the number is divisible by 3 and 5, print FizzBuzz. So let's write that exactly as it is. So we're going to do another else if. Our num modulo 3. So else if number modulo 3 equals 0, because it needs to be divisible by 3 and 5. How do we do an and? We learned how to do ors and ands, and we need to do an and here. So let's do ampersand. And we can say num modulo 5 equals 0. So now we have two things. So remember, when there's an and, what's on the left has to be true, and what's on the right has to be true. And we're gonna say when it's divisible by 3 and 5, go ahead and print that print line. What are we printing? Fizz, Buzz. All right, and this is the first way that I see everyone do their problems. And this is the oh, hey, Coding Garden, welcome. Good to see you. What were you guys working on tonight? Nightbot is doesn't like somebody. Thank you for the raid. I think it was the third raid of the night, so I appreciate that. Thank you for the raid. I like your coding garden that you planting the seed. Appreciate everyone. Welcome. For anyone who doesn't know, this is just we run bootcamp style training. So we on Sundays and Tuesdays we have a DevOps bootcamp. On Mondays and Wednesdays we have a Python introduction to coding with Python bootcamp. So we're running two. So we stream Sunday through Wednesday. So tonight we are just finishing up some. Part 2 of coding with Golang. Go is a common DevOps coding language. So we're just doing a two-parter for coding, and then we're diving into Linux next week. So that's all we're doing, just to get you guys up to speed. You're working on React and TypeScript setup. That's awesome. Hooks and state management library called Easy Peasy. I actually just looked into Easy Peasy recently for something that I'm trying to work on. I'm really trying to step up my my web dev skills, just because I partly do web dev at my main job, and I've been, I've kind of got a good handle on the DevOps stuff and the systems admin stuff and cloud computing, and kind of the back end stuff. So that's awesome. So actually, everyone, Coding Garden is a pretty great channel. Definitely follow, check them out. There's a lot of cool stuff. You can definitely learn a lot there as well. So I appreciate the raid. Appreciate you coming on over here. Cool. So right now we're just working through FizzBuzz. We're working through FizzBuzz and Golang, but we're just trying to figure out how to solve FizzBuzz for the first time. So we're getting close to the end. We're definitely getting close to the end here. So what we do have here is, now, the first time I see people try to solve this, this is what they do first. They do the num modulo 3 equals 0 and num modulo 5 equals 0. And this is a perfectly reasonable first step to get to. This makes sense. It was written out as if the number is divisible by 3 and by 5. Well, thanks everybody for the follow. I just want to thank everyone now, just because I want to make sure we get through this FizzBuzz tutorial. But thank you everyone. I really appreciate you coming through. I hope you enjoy the content here. But 3 and 5. So let's run it and see what happens. It was written out just like this, divisible by 3 and 5. We did 3. We used our new ampersands, and 5, and we combine these two to get this statement and to do FizzBuzz. And let's go ahead and test this out, and let's see what happens. Oh man, that was the wrong command. All right, I'm scrolling to the top, and you can already kind of see that there are 0, FizzBuzzes on this list. We've got Fizz 1, 2, Fizz 4, Buzz, Fizz 7, 8, FizzBuzz, 11 Fizz, 13, 14 Fizz. So we don't have any FizzBuzzes on here. Very interesting. What is a number? What's the first number you can think of that's divisible by both 3 and 5? Where should we have seen a FizzBuzz? The first number I can think of that is divisible by both 3 and 5 is 15. Whoa, aren't we hour past schedule? Yes, we are hour past schedule. We finished up with the Git stuff, and this is just kind of extra. People seem to like to hang out. We are hour past schedule, but we've been hour past schedule almost every night. It's been, we definitely gotta start reining it in. But all good. We're once we finish this up, we'll have learned a ton in this amount of time. But yes, Acid Spark 15 is the first number that is divisible by both 3 and 5. And you can see here when we got to 14, 15, we did not print out a FizzBuzz. We didn't print out FizzBuzz. And interesting, why did it print out Fizz? All right, it printed out Fizz because when it goes through and it runs through the if statements, remember I said it does them in order. So it evaluates the first block first. So it says if number is divisible by 3, go ahead and print out Fizz. And is 15 divisible by 3? Absolutely. So when it does that, it drops out of this and it goes through the next loop. So once it matches one of these blocks, that's when it ends. It matches one and it drops out of here and it goes to the next iteration. But basically, that's not what we want. It did what it's supposed to do, but that's not what we intended it to do. So there are two options here, and so usually the first option people do is go ahead and take this, and they know the order of operations. So they take this and they put this up at the top, and we can do that. Let's do that and see what it looks like. So if num modulo 3 equals 0 and actually, let's go ahead and num modulo 5 equals 0. Go ahead and print out FizzBuzz, and we'll change this line to we can leave it 5 for Buzz, and we can leave it at 3 only for Fizz. So this is absolutely a way that people go ahead and try this. They switch it up and they say, I want you to evaluate this first, and then check the other two. So perfectly reasonable order of operations here. Let's check out what we get when we run this time. Doesn't work. I missed something on line 16. Oh yeah, I missed the, I removed too much there. Equals 0. All right, so now we can automatically see some FizzBuzzes, and it looks like this works. So 0, 1, 2, Fizz, 4, Buzz, Fizz, 7, 8, Fizz, Buzz, 11, Fizz, 13, 14. When we get to 15, FizzBuzz. So if 15 is the first number that's divisible by both, it stands to reason the next number that will do this is 30, which is FizzBuzz here, and then at 45, and then at 60. So this works. This is an absolutely acceptable solution to this problem. It does work, but it's very dependent upon your ordering. Actually, they're all depending upon your ordering, so that doesn't really matter. But the easiest way is every number that's divisible by both 3 and 5 is also divisible by what number? 15. So you can make this a little bit easier and a lot cleaner to say if num modulo 15 equals 0 as your first item, then print FizzBuzz. And this is the same thing. So now you made your code just a bit cleaner. And we can go ahead and we can run it again. And we've got our same output. We've got FizzBuzz here. We can not start at 0, that's fine. But we'll leave that in. But this is FizzBuzz. The first time I heard about it, I remember the first time I was like learning the code and I heard about FizzBuzz, and it took me a long time to solve it. It took me a really long time to solve it. I didn't get any help. I was like, man, I'm just gonna practice. I'm gonna just see what I can do. And well, it didn't take me a really long time to solve it. It took me a long time to understand, one, that if statement evaluates it drops out on the first. It stops evaluating after the first one that it reaches. It doesn't match the best one. It picks the first one that it matches. So that took me a little while to understand. And honestly, the thing that took me a long time to understand was just looping through 100 numbers was pretty tough. I thought the if else's made sense to me from the very beginning. And it took me a little while to understand the 15 thing, but I felt really dumb afterwards about that. Like, it's something I certainly understood. I was just thinking, I was reading these very strategically. I was kind of afraid to think bigger than what the problem asked for. I was a little bit afraid to think about what the problem asked for, or think bigger than what the problem asked for. So this is how you would solve it. And again, it's going to be very similar to everyone who's in the Python Bootcamp. It's going to look very similar to this in Python. Very, very similar, same thing. But yeah, that is this. So if you're on Exorcism, the one that's like raindrops, this one, which is the same thing. You can see print, pling, plang, and plong, but they just have different numbers. So it's not quite the same as FizzBuzz, but it's very close, very similar logic. So I'm going to push this up to GitHub right now. I'm gonna push up to GitHub, and you can pull it down and you can just take a look at it. You don't have to, again, it's okay. It is very okay for you not to get this right now. It's the concepts. The concepts I want you to understand after these last 2 days of coding. I want you to understand variables. That there's these placeholders that you can assign values to, that these values can change. That's why the word is variable. These values can change, is a representation of a value, and you can reference that everywhere and get the value. I want you to understand data types, so strings, think quotes, words and phrases. I want you to know about integers, so whole numbers, and floats, which are decimals. I want you to know about Boolean values, which are true and false. It's simply just true and false. That's what a Boolean is. It's either true or false. I want you to know about comparison operators. So I want you to know about the equals, double equals, comparing two things are equal, greater than, less than, greater than or equal to, less than or equal to. I want you to know that you can also combine those comparison operators with and, so double ampersands, or. So or is one of the two being true, and is both of them being true to evaluate to true. I want you to remember functions, that functions are these reusable pieces of code that can take in data, that can take in input, and also can output data. Remember, those have the little return statement, and they return data that way. I want you to know that there are loops. And again, you don't need to know how to write these things, but you need to know that there's a mechanism within coding to be able to loop through logic as many times as I tell it to. So again, now you have a tool. That's like right now, I know that a screwdriver exists. I may not know how to build a house with it yet, but I know that it exists. I know it's available to me. So when I'm going to build this house and I get to see a screw, I have an idea that maybe I can use this tool that I learned about to solve it. That's the same thing we want to do with these different pieces. So we want to learn about loops. We want to learn about the math operators. We know that we can do math here. We did it here with modulus or modulo. So addition, subtraction, multiplication, division. We can increment and decrement. So we can add one and subtract one with this plus plus or this minus minus. And those are kind of the main pieces of coding that I want you to understand over 2 days. Those concepts, again, you don't necessarily need to know how to implement them, but know that they are a thing, know that they are available. Write those things down. And start to dive into those things. And as you start to solve more problems, you'll start to see why they're valuable, how you can use them to solve other problems. And I'm trying to think about what we did as opposed to what we're doing in Python. But yes. So what do you do from here? Again, Exorcism is something great to tackle. And again, I don't necessarily think you need to code to the Exorcism problem up front, but I think you should read them and start trying to do them on your own and just Googling answers to them and things and seeing if you can run through and maybe getting a mentor to look at what your stuff is. But I don't necessarily think Golang is the language that you need to know first. I think you were someone who is familiar with a little bit of code already, and most of these concepts were either relatively simple for you or things that you already knew. I would recommend you pick up Golang. I do think it's a language that'll make you, I think Golang will make you, especially if you know an interpreted, if you only know interpreted languages like Python, like JavaScript. I think that Golang will make you a better programmer. Learning a statically typed compiled language will make you a better programmer. So I do actually encourage you to pick this up. But if you're someone who joined the DevOps Bootcamp and has zero prior coding experience, Python is fine for you. I mean, Golang is fine for you to pick up. But if you're looking for something that this seems pretty intimidating to you, Python might be equally as useful in the industry, in the field of DevOps, if not more useful, to be honest, right now. But I think it has a lower learning curve. It definitely has a lower learning curve, to be honest. So if you're just looking to build and you think that this was very, very overwhelming, then feel free to hop into the Python Bootcamp or learn Python instead. But the key is to practice. And again, I'm going to be talking more and more about putting a framework around this 100 days of code thing. It won't just be you on your own doing this 100 days of code. We'll be having frequent check-ins. We'll be having frequent challenges and things, benchmark things throughout the process for people of all skill levels. So beginners, intermediates, and advanced, to really build our skills. And again, that'll probably start in 2 weeks. I need to check it again against what the curriculum is for the Python course. But I want to make sure they're in a good place to really participate as well. But yeah, so next week we're into Linux next week. We're out of the coding. We're into Linux next week. 3 streams of Linux. So you're gonna learn how to really manage a system. You're gonna learn all about the command line. You're gonna learn how to manage a computer from this terminal right here, the same way you've been seeing me do it. You're gonna learn how to do exactly that as well. So hopefully you're looking forward to that. And again, if you want to learn more coding, definitely hop in on Mondays and Wednesdays for the Python stuff. But that is it. Let me answer any questions that were asked that I missed out on just because we were trying to finish up. FizzBuzz lost me a junior DevOps position. I went too heavy on the AWS studying. Yeah, that could happen. That definitely can happen. It's interesting. I've never seen anyone. I've never been asked it on an interview, and I've done a lot of interviews. But it's something that's good to know. Again, and I think most of the interview questions, like the common interview problems, they follow a similar thinking paradigm. So if you start to practice some of these common interview questions, the concepts kind of start building up across all of them. And I think unless you're out in Silicon Valley, I don't think you should get questions that are much harder than this. And I've actually only had I think the hardest DevOps interview, like coding problem I have. I usually don't get any coding ones for DevOps. I think the hardest one I had was I had to make an app that did like temperature conversion between if you pass in Fahrenheit, you can make it either Celsius or Kelvin or something like that. And I could switch between the 3. So that's probably the hardest one I did, which is actually fun because you can get when someone doesn't give you a lot of parameters and says, just go do this thing. I ended up making the app a lot bigger than it needed to be, just a lot more functionality than it needed, but it was fun. It was definitely fun. Maybe we'll do something like that. We'll do something like that. I think that's actually a really cool project. Okay, so do we have a for each and go? No, you do not have a for each and go. You do not have a for each and go. Go actually provides very little of the very friendly helper things like for each. But I actually like it because of that, because of its scarcity of magic functions. But for each is great. But it is not just not have a for each. It's pretty cool stuff. Appreciate that. I really appreciate that. Why are there no parentheses in an if statement? That is how the source code was chosen to be written for Go. You don't need them. I actually think I put them in there earlier, and I think it removed them. I think it actually removed them for me, maybe I removed them and maybe aired it out. But I don't know. But Go does not need them. Did you teach about types like N64? Yes, I did teach about types like N64, the ones that are requiring more data if you need larger numbers, more memory allocation, more bits and bytes and all that. Yeah, we did go over N64s and float 64s and runes. We went over runes as well, and we know that that is a what is it? It's an alias to N64 or N32. I'm not sure, but yeah, we did go over those things. But I say to the end that least common multiple was cool. Yeah, like it's math, it's simple math that you kind of forget over the years, to be 100% honest. So cool. Cloud on Fleet, gotta head out. Have a good night. Appreciate that. What about updating NVIDIA drivers? I did no. This computer doesn't actually have any NVIDIA drivers. This machine is actually running AMD. It's my first AMD graphics card. To be honest, but it's working out pretty cool. What distro are you planning on using? So the distro I actually have on this computer right here is Pop! OS. I'm probably just going to install Ubuntu. I don't know. It's a good question. I think last time we just installed Pop! OS because it's basically Ubuntu, but we're probably going to install a base version of Ubuntu. Maybe I was thinking maybe CentOS, but I actually wanted to give people a desktop to be able to work out of. Yeah, I didn't get any feedback if that was a good thing or not, because I don't know how powerful people's computers are. But when we do the Linux virtualization stuff, we'll probably just use Ubuntu for that. Arch, I used to be an Arch user. Now, again, I use Pop! OS right now. I'm a simple guy now. I don't need. I don't really want to spend as much time, making sure my stuff is as good as I used to. So, this works for me, and I kind of stick with it. I appreciate that, Steven. I appreciate that. You shouldn't be installing NVIDIA drivers from source. Any modern distro will allow you to update them from SPM. So if you are trying to run Linux with NVIDIA drivers, I'm telling you, Pop! OS has an installer with NVIDIA drivers already installed. And I've been using Linux for years. And it has been the easiest, I've had the most success. Like you just install it, it just works. Like it just works. Pop! OS has built-in distro ISOs with the NVIDIA drivers already kind of set up and ready for you to go. And yeah, I would absolutely recommend that if you're trying to set it up on anything like that. I did FizzBuzz on a single line, and they thought I was yes, and they thought I just memorized it. Yes, I've seen FizzBuzz single liners. Yes, that's really funny. And you should have said, even if you did memorize it, you should have said, and like I also memorized how to write a function in this language. Like, yeah, I memorized it. Like it's fine. I can explain it. Like even if I memorize it, if I can explain what's happening, that should be fine. You shouldn't ask me a question that is common. Like, so what? I don't care. Go is devoid of syntactic sugar. Absolutely. So that is a great little word that people may not be familiar with, but syntactic sugar is when a language provides you an easy way, an easy structural way for you to do something that might be a little bit complicated, so that you don't have to type a bunch of stuff or know how to do a bunch of stuff. So syntactic sugar is yeah, it's the magic that I was talking about that some languages have that Go doesn't, where you can do like a for each, and underneath that for each, it does a lot of the work for you. Go, you kind of have to do a lot of that hard work yourself. So that's perfect. It does not have that. Cool. We got parentheses. Ifs are optional. Bullseye for the devs. Gen 2. I like Gen 2. Gen 2 is cool. I've had terrible luck with AMD graphics cards. Everyone I've ever used had issues, just bad luck. So that's funny because I had a single one before this, and I had it for a day, and I returned it because I had all kinds of issues. But I got a deal at Micro Center. I actually did an all AMD build, and it's an AMD build for video editing. So I have the highest, like was it the Radeon 7, and I switched over to DaVinci Resolve. And so it actually, man, it renders. I rendered out a video that I used to render out of Adobe Premiere, like a 4K, like a 7-minute video, and it rendered on here in like 3.5 minutes. I was like, oh, this is great. This is great. So that's the only reason I went with it, but it's working fine right now. I've never had issues. Cool. Yeah. All right, it's late. It's very late. I need to get to bed. Tomorrow is, again, tomorrow's Python. If anyone's trying to hop in, tomorrow in Python, I think we're just talking about, we're just getting on diving deeper into data types. So we're really gonna be diving into data types, just doing like seeing some string methods and stuff like that, and practicing that, and seeing just kind of how things interact, different data types interact and things like that, and what options you have available to you. So if you're still trying to pick up coding and you still want a lot of the basics, that is the course for you. So head over. But I'm definitely rating the Primesian, but that is what you can do. You can hop over tomorrow. If not, I'll see you all. Get ready to learn some Linux on Sunday. We'll be back on Sunday. Thanks for another successful week 2. We're gonna go ahead and raid one of my favorite streamers, who is the Primesian. I hope that's how you pronounce his name. But we're gonna head over there in a second when I get over to the screen. Let's do it. Raid. And I can hear my voice twice. And let me type it in properly because I can't type. Is it they should Parmesan. Okay. All right, cool. So we're gonna raid the Parmesan or the Primesian or whatever, how you pronounce his name. I'll find out tonight, maybe. But everyone have a good night, and I'll see you later. Reach out in the Slack or in the Discord if you have any questions. You can get the links for both of those things through chat commands if you need them. Have a good night, everybody. Let's go. It's gonna take us over there in 10. Nah, let's do the countdown. 7, 6, 5, 4, 3, 2, 1. Everybody have a great night.